Mic check.
Hello.
So welcome everyone. Today we've started with a session from Philip Miglinski from Glasscube. He's going to talk about rethinking package management in Kubernetes with Helm and Glasscube. We have a QR code on the slides for Slido. If you have any questions, we're going to have a Q&A in the last 5 minutes. The floor is yours. Thank you.
Perfect. Perfect. You can see the slides. Thanks for the introduction, and very happy to arrive in Prague and give a talk about rethinking package management in Kubernetes with Helm and Glasscube. Sadly, I'm standing here today alone as Anais couldn't join, as she just started a new job and advanced in her career. So I'm gonna sadly introduce only myself. My name is Philip Miglinski. I'm from Vienna. I studied at the Vienna University of Technology. And after my studies, I built up an alerting company for firefighting organizations back in Austria. And in my free time, I actually used to play uni hockey quite a lot. So I was traveling a lot to Czech and Finland and Sweden to play there. But yeah, we lost all the time against Czech. I think you're way better, and even against Slovak. So yeah, we have no chance in hockey against you guys. So yeah, but I started the startup journey 2 years ago with Glasscube, and really happy to connect. These are like my LinkedIn and Twitter QR codes. If you have any questions also afterwards, feel free to reach out. But I couldn't do Glasscube and the whole talk and the preparations alone. It's really an experienced team that stands behind Glasscube. We are now a team of 6 people, having all a lot of experience in DevOps, Kubernetes, and building startups and open source projects. And we also want to thank our community before every talk. We have like over 120 people in Discord. We make regular community meetings. And I think we have now over 30 contributors, of which 5 are really, really active and shaping the future of Glasscube. And they even give talks around the world. So it's not just me promoting Glasscube. It's our contributors all over the world. But enough about Glasscube, let's talk about package management, right? So the first expectations you have when you see Kubernetes and you work with Kubernetes is great. You get Kubernetes and you can deploy a platform and you're ready to do so. But in reality, that's quite different, right? You need a lot of packages, a lot of components, and it can become messy quite shortly. So reality isn't always like sunshine and happy time. And what Casey Hightower once said, Kubernetes is a platform for building platform. It's a better place to start, not the end game. So if we have Kubernetes, we only have the foundation, and we still need to do a lot of work to get your core application or to get the stuff you really want there, and we really rely on a lot of packages, right? So we have a platform, and a developer provides tools and infrastructure to streamline the development, deployment, and manage applications. And we just saw it in the other room. These kind of packages and applications we rely on, they can be found on the CNCF landscape, and it's an ever-growing list of applications. We just heard in the other session, it's from security, delivery, and many more tools. And a phrase that I like to establish kind of in the world is the DevOps sandwich, right? There's Kubernetes at the bottom, which is solved by either on-premise solutions like Ranger or Tanzu, and there is a lot of application and packages in the middle, which your core application relies on. And your core application is really covered by your CI/CD, GitLab, GitHub, and really a lot of applications and developers focus on making your core application rock solid and good. But all these packages in the middle, they are kind of left alone. Yeah, you have Helm, but you need a kind of better way to manage and bring these tools or these packages into production. And that's now, like Kubernetes just turned 10 years old. And what kind of tools do we have to bring these packages in the middle of the DevOps sandwich to production? So one of the first tools or ways to deploy these packages have always been manifests. Then with the introduction of Kustomize got eventually merged into Kubernetes, kubectl. This is a simple way to reuse some of the manifests and create overlays if you have some specific changes you want to make for specific environments or specific clients, customers, or teams. Then, of course, we have Helm, which we're going to explore and dig down in the next couple of slides. And we also have some new kind of package managers focusing on OCI image, like Timony from Stefan Prodan or Glasscube, where we focus on user experience and security. But first, let's start with the oldest kind of package manager or packaging tool we have. It's Kustomize, where you can easily apply patches or overlays to specific base configurations, and then make sure you have like different variants deployed for different scenarios, but still sharing a lot of the same manifests. And there are still some applications out there that recommend the deployment using Kustomize, but this can get quite messy. So Crunchy Data's Postgres operator, for example, they still recommend you to fork their customized GitHub repository, then apply or then write your own custom configurations in patches, and then every time Crunchy Data create some changes in the base customization, you need to like rebase your repository on top of the customized of the Crunchy Data deployment repository, which is really, really not good practice. And we also run into a lot of other issues with Crunchy Data. For example, they just they give you like Postgres images, but only the last couple of, this only support the last couple of versions. So if you don't immediately update your Postgres version from the Crunchy Data container registry, they will then put the containers behind the authentication, and they say, yeah, sorry, you now need to get the enterprise license if you want to use like Postgres images, which are not last couple of months old, which, yeah. This is also what we don't like, and it's generally not recommended to bring applications in that kind of way to the production cluster. And then we obviously have Helm, right? Helm is nearly as old as Kubernetes. It was started in 2015 as a hackathon project from Deis Labs, which is a cloud-native consulting company. And it was originally in version 1 built as a client-only tool. And in 2016, it was then actually merged with the Kubernetes Deployment Manager, which originally came from Google, and which was a server-side tool. And they then brought the code bases together, and in 2016, it got released as Helm 2.0 with the server-side component Tiller. And this actually, I don't know who in the room actually worked with Tiller, but it had a really lot of performance issues, and you couldn't install more than a couple of charts, and in the end, it always crashed. So there was a big community motivation to refactor it again, and to again release Helm 3.0 as a client-side tool back in 2018, which is also like 6 years ago. 2 years ago, they released support for OCI images. So Helm charts no longer need to need to be fetched from a Helm repository, but you can also like reference OCI images, which has also some downsides, but in the end, Helm is now a tool which is also over 9 years old. I think we all used it, we all learned a lot of it, or from it, and we can now look under the hood of what Helm does. I mean, it obviously has a lot of good things. It allows you to bundle your applications with Go templates inside of YAML files, so you have like more dynamic ways of create your YAML configurations, has built-in variables. You have a place where you could put your custom resource definitions, and you obviously can release multiple versions or revisions which are stored inside of secrets of your Kubernetes cluster. You have the possibility for subcharts, which in theory is a quite a nice concept to reference on another chart, like kind of a dependency, but yeah, in the end, we have to take a look what the subchart actually is in Helm. But one of the greatest features or good things about Helm is great ecosystem support. Artifact Hub has an awesome place to list these kind of Helm charts. A lot of people can contribute, and it's at the moment, I think every one of us has a love-hate relationship with Helm, but you can find a lot of Helm charts all around. How do revisions actually in Helm look under the hood? If you look at the namespace where a Helm chart gets deployed, every time you release a new, make a new deployment, a new revision from the Helm chart is created. So you have a new secret. I think it's called something with Helm revision something, and it's double base 64 encoded state of your values file, and this gives you the possibility to easily roll back to a previous revision. And if you open one of the secrets, we're going to see this base 64 encoded string, and in the bottom of the slide I put a command on how to get and extract the values. I think it's double base 64 decoded and then still gzipped. But yeah, as an alternative, you just could run Helm get values and you get the same state. So what are the challenges of things that a lot of users and we think that makes Helm also a challenging tool to use? Obviously, the Go templating engine is kind of messy. You don't see during creation of Helm charts if there are anything breaks. You always need to template it out and apply it to see if you messed up the Helm chart itself with the Go templating engine. And there are so many commits fixing Helm charts because something is either wrongly configured or if else is just not right and the Helm chart doesn't work. So it's not a clean and type safe way, and you have hardly any auto-completion. We already learned that Helm 3.8 has an introduction of OCI images, but if you reference an OCI register in Helm to get your deployments from, you have no possibility to search them because this is not how OCI registers works. And also some of the, I mentioned before, like custom resource definitions have their custom place inside a Helm chart, but you always need to be aware of that these custom resource definitions don't get upgraded by default. So you need to use some kind of deployment mechanism, like, I don't know, Flux Helm controller to explicitly upgrade these custom resource definitions, or a lot of Helm package authors just put them into the normal template files so then they can get updated as well. But this is also something you really need to be aware of, and which is not something novice cloud native developers think about. And yeah, Helm update is also something which, if it's executed by us as a user on the command line, you need to be really cautious of just running Helm upgrades, because if you also reference the values in kind of the CLI command, and another DevOps engineer on your team tries to also update an Helm chart and supplies other values, the previous values are just lost and overwritten. So you also, if you don't use any GitOps approach where you manage your Helm charts and just use the command line, you really need to be aware that if you update Helm charts and not provide the values file in some kind of synchronized folder, you might break your Helm release. Another point about package management, and if we really want to rethink package management, we need to talk about dependencies. Yes, there are subcharts and umbrella charts in Helm, but if you reference a subchart, the subchart will always be installed in the same namespace as the original chart. And there is no way to reference a dependency of a Helm chart and kind of reuse it. So this is really, you really need to be aware of. So, and this also leads to tools like GitLab not actually recommending their Helm chart for production installation, as they, in order to make it work, they're gonna put a lot of stuff in there, like I think the whole Kubernetes stack, databases, so on and so on and so on. And this will eventually, if you perform these Helm upgrades, break. Because if you have a subchart if I have a subchart, for example, a database, and the main chart upgrades the subchart's major version, the database will often break because there's no kind of migration script or migration possibility in this kind of database, standard database Helm charts. So for example, the Bitnami WordPress chart, for example, if you just install the default one and upgrade it, it sometime will magically break because the MariaDB chart is just upgraded to a major version and no database migration will be performed. So you need to back up the database or use some database operators, actually like MariaDB operator, Cloud Native PG, for example, and you can should reference them and create your clusters or databases accordingly. Or another package we already heard about in the second room, like Captain. Captain has a hard dependency on some kind of cert manager because they're working with admission webhooks and validation webhooks. And if you want to talk with the Kubernetes API, you need SSL communication. And in order to do SSL, you need a certificate, cert manager. So they always struggled, should they include cert manager in the Helm chart or shouldn't they? So it's always 50% of the users already have cert manager and 50% doesn't. So they just ended up forking cert manager. So they don't, it's not no conflict if you already have the cert manager installed, but you end up having 2 cert managers installed, which is also no scalable way of doing package management, because what you should do is just define a dependency on cert manager like every other package manager does, and then you have it. So this is why we actually released Glasscube, or why we thought about creating it. And beginning of the year, in February, we tried another cloud native application where we released the Helm chart and said, yeah, please, people, try us out. And we got a lot of feedback that using Helm, people don't really enjoy using Helm. People were afraid of Helm, and all the dependency situation was really messy. So in the end, we just said, okay, so many people complain about Helm, so many people want us to rethink package management, so we just actually do it. We came up with a concept of a new package manager, which has a server-side and a client-side component. And we released the first architecture preview in January, and it was immediately picked up on Hacker News. We got a lot of feedback and positive comments and encouragement. So we actually started developing it. And I think in March or so, we released our first alpha version. And a couple of weeks ago, we actually released our beta version, having now already 15 packages on there, and seeing quite a nice adoption also in bigger enterprises and clusters and DevOps engineers who really are, I don't know, they are fed up with Helm and want to have an easy way to install their packages. So what does Glasscube actually do? We try to be the next generation package manager for Kubernetes. And at the moment, we don't want to reinvent the wheel. Under the hood, we still use manifests, Helm charts, and in the future OCI images, but we really focus on dependencies, user configuration, simplicity, and automated automated version checks. So we kind of got a lot of inspiration from Homebrew. They have a central Homebrew core tab, how they call it, and a lot of packages are placed in there if there's a new package version out there. The Homebrew core repository will, or the bots in there will create a new pull request. Then there will be a lot of CI/CD jobs validating that everything is good, and then it will be merged into the core repository. And on the other side, there are like custom tabs. So if a package author wants to expose his package with for Homebrew, he can just host his own tab and create, like, I think it's a I don't actually know what file format it is. Some Ruby file format probably. Create it there, and you can add the tab and just use the package chef. And this is exactly how we do it. We have a core repository where we try to collect all the packages, but if some package author wants to provide his package via its own repository, which is not yet in the core repository, he can just host its own repository and link to the user that he needs to add the repository, and you can install it. But every packages that are available in our core repository are tested and can be used and referenced as a dependency. So we have dependencies and compatibility checks. So all the packages are actually have a semantic versioning, and if you require a specific version, you can just say, okay, I have a dependency on this version or on this Kubernetes version, and we make sure before package installation that all the requirements are set. And we are also GitOps ready. We are currently working with the guys from Renovate. I don't know if any Renovate contributors here. They're doing an awesome job in keeping all our GitHub and GitLab repositories up to date. And I hope in a couple of days or weeks, also GlassCube packages will be recognized by Renovate, and we receive automatic updates. And yeah, we're also working on our own cloud that will also give you even more merge confidence, so you get insights of if your desired package version, if your Kubernetes version is compatible and has already X amount of adoption, you can safely merge it. So kind of auto-merge Kubernetes packages in a real world with real tested environments. So GlassCube under the hood, how does it look like? We have a client which it's written in Go, has the Cobra CLI, and a UI which is written with HTMX. Actually, fun fact, Git is now also using HTMX, server-side pushes for real-time updates. This client then talks via the Kubernetes API, obviously, to our package controller and package info controller. So GlassCube itself doesn't require any database or third-party tool. It stores all the information via custom resources in etcd and fetches then packages from the public GlassCube package repository or your own configured package repository. Make sure the deployment instructions are available in your Kubernetes cluster together with some validation stuff, services you want to expose so people can actually use your package and open the package. And every time there's a new version available on the central package repository, our package info controller actually will fetch these changes and show it to you in your UI or CLI. You can update the package, or Renovate will do this if you manage your packages with the GitOps approach. So I'm going to do a short live demo because I think I talked already a lot, and it's time to see how GlassCube looks in action and what our approach of rethinking package management in Kubernetes ended up. So, oops. Let's see. Yeah, we'll be fine. I'm gonna share the screen so I can duplicate it. So, first thing I'm gonna do is I increase the font size of, I think 15 was always a good trade-off. Does it work good? Perfect. So I think even bigger? Okay. Like this? Perfect. So we're going to start up the demo with a really fresh Minikube cluster. I don't know, most of you probably always also use Minikube for local development. And I think it's one of the nicest tools to do testing and starting. So Glasscube is a CLI program. You can install it obviously via Homebrew, or you can install, download our binaries from our website or GitHub releases. And we can look at which packages are available. But in order to do so, we need to bootstrap Glasscube. So Glasscube itself, as I said, has a client-side and a server-side component. And the first thing our CLI does is recognizes that the server-side component is not yet here. So we can bootstrap. This will fetch all the manifests and make sure that our server-side Glasscube component is ready. We always see our two main points of contact, which is our GitHub repository, and there's actually a typo, and our Discord channel. We always also have like a space in the CNCF Slack and are present in the Kubernetes Slack, but we try to do our community calls and community management via Discord, as we think it's a little bit nicer. And yeah, just takes a couple of seconds, so everything is done. Perfect. Glasscube is installed, and we see we already support the first couple of packages. They are not yet installed, and we can also explore our packages via. I'll just open the UI via the Glasscube serve command. So we have a UI where you can also easily install every kind of package. So for example, let's install Argo CD and look how you could manage further Glasscube packages in the GitOps approach. So we can install an arbitrary version, enable auto updates if you want that, and just install Argo CD. You're going to see it's pending, and it always also already provides some kind of open command. But before we do that, we're going to install more packages. For example, install the Kubernetes dashboard. Kubernetes dashboard is also one of the tools I really like to visualize what's happening inside the Kubernetes cluster. They recently created a new major release where they introduced, I think, Kong as a hard dependency. So we are still working on this major version migration, but at the moment we are fine with the version 2.7. So maybe install one more package via the UI. And also, if we try to be a kind of package manager, also provide like comments, so we can people can upload specific packages or comment on packages, and all this kind of information is then stored in GitHub discussions. So we are using Argo CD at the KCD Czech Slovak. So let's see if it works. Perfect. We have now a comment on the Glasscube package manager for Argo CD. Yeah, we can install more packages. I don't know. Yeah, Cloud Native PG, as we want to have a meaningful database operator in the background. So let's look at the. Let's go to the Argo CD namespace. Look if everything is good. Argo CD looks good, perfect. So we can get our initial Argo CD admin password and log in into Argo CD. So in order to get into Argo CD, you could either do a port forward, but Glasscube as a package manager provides you an open command. So we does the port forwarding and plumbing under the hood, and we can log into Argo CD. Woo, Argo CD. Next thing is we want to add a package. And how does a package look? I have a sample repository with some package manifest files. So every package in Glasscube is just a custom resource. You can specify a specific version. You can specify and the name, deployment, and even configuration values. And we're gonna add Argo CD at application. let's find the command. cd create app captain. This looks good. Perfect. So we created the captain application, and we're gonna now see in Argo CD in real time that the captain application is here. We just need to sync it, and we're gonna see that syncing Argo CD will first install Cert Manager, because captain in the GlassCube package version has a dependency on Cert Manager, and every other package that uses Cert Manager can reference the same dependency to Cert Manager. And in GlassCube we see in real time that Cert Manager is getting installed, and as soon as Cert Manager is getting ready, captain will then be installed. Yes, we can wait until it's to happen, and it will be done in a couple of minutes. Yes, perfect. I think we can look at this in the background and already start some Q&A, and after the Q&A we should see captain being successfully installed. So this is me. So if you want to support GlassCube, we would really appreciate your star and contribution and support on GitHub. Join our Discord or connect with me on LinkedIn. And yes, I hope I'm on time.
You're on time.
Perfect.
Thank you, Philip.
Oh, thank you.
Yeah, well deserved. So I'm going to read you the questions, and maybe you can answer. Mm-hmm. So first question, you mentioned Flux Helm controller. Is it your GitHub solution under the hood, or is it made like from the bottom?
At the moment, we're really using the Flux Helm controller, Flux source controller under the hood, as we are working on the interface and package design at the front end, and we want to exchange these components until we reach a certain API level stability. And we want to create our own package format, which can then sit in the package author CI/CD. But we still want to talk to a lot of users, a lot of package authors, and to understand how their ideal package format looks like, what they kind of require in the package format. And we just want to start building it before we talk to actual users and receive these requirements. But if you're happy to contribute, also join our weekly community call. We're going to discuss these kind of steps.
Okay, so the next one is, did you try to figure out why the Helm release secrets are double-based 64?
Good question. I actually don't know. It's also gzipped. So from my understanding, doing a gzip and base 64 should already be super safe. But maybe Kubernetes base 64's older secrets. So base 64 encoding could be done by Kubernetes itself. So maybe Helm just did one and Kubernetes did the other one. So this could be a reason.
Thank you. So there is two more. Rancher provides a very similar app store which uses Flux under the hood. So are there any major differences?
Sure. Really, Flux under the hood in the Ranger App Store, or Helm under the hood? From my last understanding, it was using Helm under the hood, but might have changed. Sure, I mean, GlassCube is Kubernetes version or Kubernetes and distribution independently. You could use us in AKS, RKS, with Ranger, or if you use your Tanzu cluster, Minikube cluster. So this is the major difference, and our main package repository, which has CI/CD tests for every new package. So a new package will only get released if it passes our CI/CD.
This one is tricky and a little bit funny. Are there any other ways to bootstrap GlassCube instead of CLI tool, for example, through Terraform or Helm?
You can bootstrap GlassCube via UI. I could show it to you later. But as we talked, we are currently working on the Renovate integration. So you can also bootstrap it with output, I think, format YAML. So you get all the bootstrap manifests in a YAML, and you can then put this into your Git repository, and your favorite GitOps tool, Argo CD Flux, will then deploy it into your cluster, and the Renovate bot integration will make sure that the ClassCube system configuration will stay up to date. And also if our custom resource definition changes, Renovate will take care of it. So yes, you don't need to do it manually, you can do it via GitOps.
We have a little bit of time, so let's go for the two last questions. So is this just a Kubernetes app store, or can we publish our private packages as well?
Yes, private packages can be published with private repositories, and private repositories can be secured with authentication. So if you want to publish your private packages there, we highly encourage you to put an authentication there. And if you configure this private repository, you might want to configure also an authentication on the other side. But this definitely works. If you have this specific use case, feel free to talk to me later, and we can help you set it up. It's not that good documented, but yeah, I need to document. We need to document it. Yeah.
Last one is tricky.
Yeah.
So what happens if the server-side controller crashes during the upgrade? What happens to my application?
I mean, this is Kubernetes. Kubernetes has this declarative approach, so I think it first tries to fix our package controller server side, and then our package controller will see in the conditions of the custom resource that it's currently in the failed state or in the pending state, and then it will reconcile it as long as it reaches the green state. We haven't yet encountered a scenario in production or for a production customer where we ended up in a deadlock. But internally, we had already some deadlocks, so there might be a possibility of a deadlock in some certain scenarios, but I hope you won't get affected.
Thank you very much.
Thank you. Yeah, perfect. Can we make a photo together?
Sure.
Perfect.
And just a note, the next session is in 5 minutes.
Perfect. Let's do a photo. Perfect. And yeah, there's some stickers or gummies. If you want to have a ClassCube gummy or sticker for your laptop, feel free to grab it.
Hello. So let's get started. My talk will be about the cloud cost, ClickHouse, and OpenCost, how that's all married together. And we will start with a little bit of introduction. So my name is Denis Kondratenko. I am working at Altinity as engineering manager for Altinity Cloud Platform. And yes, originally I'm from Ukraine, but right now I live in Nuremberg, Germany, where I moved to work for SUSE, where I was doing SAF development and management. And my past background is around the storage, Lustra, SAF, and etc. But recently I switched to the platform development. That was DBAS in Percona, and right now in Altinity, we are building the platform to manage ClickHouse for our customers and for you. And we also have open source project that helps with that, like ClickHouse Operator, which runs in the Kubernetes and manages the ClickHouse clusters. Okay, so why cloud costs? So first of all, economics, right? So as the business, we need to understand how much we spend on the cloud. And this is important for everyone. As well as we are building the SaaS solution, like we are managing ClickHouse and Kubernetes, so we need to actually bill our customers as well. So this is another reason that we need to understand what kind of costs we need to bill our customers as well. So there are our infrastructure costs as well as the customer usage, and et cetera, et cetera. So this is, for that we need also real-time data to show it both for customers and to us to actually detect some anomalies as well. And one of the applications for that is to submit this data to marketplaces. Usually when you sell through the marketplaces, you need to submit your usage quite often, like hourly or so the marketplace can bill this customer for you. So this all requires kind of real-time data as well. Whenever, and you can have other reasons why you would like to see costs, like if you are communities, you would want to manage your costs and see what kind of spend you have. Also, the environment footprint is really important, so you do not spend more and actually use more resources that you need. So you save, so reducing the carbon print. Cloud costs, what are those? So actually every cloud exposes some kind of interface. AWS, GCP, Azure, they give you possibility to see the cost on their UI, as well as to export them. But all of them are different. So AWS exposes it as the cost user report, for example, or you can upload those usages and costs to the Athena database and get it from there, like query, or maybe export it from Athena in some format or so. Also, GCP does it differently. They have a BigQuery to load your cloud cost, and then you can export it somewhere. Same for Azure. They support exporting to the blob storage, whatever you choose. So they're all different, and this is a challenge. Another one is like how often they export those costs. And this differs from cloud to cloud. For example, AWS tries to do it like 3 times per day. The Azure is doing it daily, and GCP, I think it's hourly, but I'm not sure actually. We importing those costs like once in 6 hours. And it comes with delay because, yeah, they bill you for the hour, right, of usage. But they need some time to process all that and give you actual bill, because that could be some savings plan, there could be some discounts, and etc. All of that is reflected in those reports, but still it takes time. The only common thing among those clouds, like AWS, Azure, GCP, and others, are those that they use the CSV format. So all of this data you can export to the object bucket is usually in CSV. So you can then easily import that somewhere. The thing is about cost to remember that if you have a lot of resources and a lot of infrastructure, then you probably would like to tag your resources really well to actually figure out what team uses those resources or what tenant, what customer, whatever. So one approach is to tag their resources, and all of these reports from all of these vendors and customers, all of the clouds will have those tags. So you can identify the resources and pricing and usage by tags. So on this picture, you see what kind of challenge we have. It's Alternity Cloud, right? How we do it. We operate Kubernetes. So we have our main control plane, core Kubernetes control plane is the Kubernetes, as well as we manage the other customers' Kubernetes, right? So either under our account or under customer account. So that's, for example, you give us either permissions, like for project in GCP, or some access rules in AWS, and we provision resources under your account. Or you just connect any Kubernetes you want to us. So all of those are managed Kubernetes, either those managed by customers, or we prefer to actually roll the managed Kubernetes, either EKS, GKE, AKS. So we operate the Kubernetes. This shows like how we do it. It's like either like we provision it by our control plane, or you provision it yourself, and then we manage it from there. And as I said, this is what we do is ClickHouse. And on this slide, on this managed Kubernetes, we run ClickHouse database, and it's stateful, right? From one perspective, for cloud cost, it's a little bit easier because the load and databases are more or less static in terms of like, if you have like 10 replicas, 2 shards, that will be probably staying there and will not scale up, scale down too much. But from one perspective, it's easy because we don't have like kind of dynamic workloads. From other perspective, running stateful applications in Kubernetes, it's a different challenge. So we manage ClickHouse, and ClickHouse is the real-time database, real-time analytic database, which actually designed it to ingest a lot of data and analyze it really quickly. So it's used on all kinds of analytic applications to have snappy dashboards to analyze the logs, security logs. A lot of FinOps applications, etc., use ClickHouse to load it with the data, analyze it, and then proceed with the results. So it's also could be used as part of data warehouse, if you're familiar with those. And this one is scaling really well. It supports replication, sharding, all of the nice features. It's column-oriented and utilize resources really well. So this, if you allocate some resource to the ClickHouse database and ask it to proceed something, it will utilize everything on that node and whatnot. Another player in this picture, and most important one, is OpenCost. And when we came to the problem that we need to measure those costs, the OpenCost was already there, and it was an obvious solution for us as well. So OpenCost is the open source Kubernetes and cloud cost monitoring tool, not tool, sorry, solution. It's implements, it's actually defines the specification and implements the specification for vendor neutral cost management and infrastructure cost management in Kubernetes. Here on this picture, you can see that it actually gets its data. The Prometheus is required. It gets all of the data from the Prometheus about the containers, about the usage from a couple of sources, scoop state metrics, as well as from cAdvisor about all of the containers running, what kind of resources they consume. It's usually CPU, memory, if you have GPU, disks, all of that stuff it measures and reports back to Prometheus or other sources. Recently, I think it's from the past, in the last year, they added also cloud cost support. So you can measure not just usage, but also get the actual cloud costs. And as well is uploading the pricing, is downloading the pricing from the cloud providers, like what resources cost what. For example, these instances, disks, etc., specifically for this class, what those costs, calculates all of that, and gives you back as the result. Like, so the three main parts of open cost feature is the pricing, is the measuring of actual cost for the containers, so it looks into what kind of nodes it use, storage, and etc. And third one is it also can download the actual cloud cost. So it provides both real-time metrics about your usage based on pricing, as well as then later shows you actual usage that's actually a little bit behind. And kubectl that is upstream, that's actually vendor project, it's also can then reconcile those costs for you. And kubectl also have neat features like analyzing the anomalies and alerting, which is really, really important. But OpenCost doesn't support it, so you need to build it yourself. And then you can get this data from either API that OpenCost provides, or it also exports these metrics to Prometheus. So you can scrape the OpenCost, and it will provide you all the metrics about your containers, how much they consumed, what is the cost of was for this workload. In our case, it's a little bit simpler because there are few ClickHouse servers running there, and we have like tens of the servers like reporting that what costs for those, and usually they consume whole the node. In case of the smaller pods, there are some errors could happen, and there is the nice table in the OpenCost documentation, like what are those errors could be, what are deltas, etc. So if you have smaller workloads, you probably need to check those, what kind of errors OpenCost could give you. Also, it exports to CSV, Parquet, and other formats, so you can check that out in the documentation. This is how, like, a simplified scheme how a tenant looks like. So it usually runs on the cloud, and there is the Kubernetes, whatever. It's EKS, AKS, we don't really care. And inside of it, we have two important parts. It's first of all, ClickHouse, where there is a ClickHouse operator that manages ClickHouse, as well as zookeepers. Zookeepers are needed for replication between the ClickHouse over there. And this is what we actually observe, right? We also have observability stack deployed for each tenant, each customer, to troubleshoot issues, to actually monitor what is going on. We have logs, we have Prometheus over there, and obviously adding OpenStack there was easy. So it's kind of per customer, per tenant, per cluster OpenStack running over there and collecting the metrics about this particular cluster. Then it comes to us, right? All of this cloud data we collect to Victoria metrics. So all of the Prometheus, we run like hundreds of them, then we just push different ways. We push this data either by simple like remote rules from tenants that are under our account. They are pushed to the Victoria metrics and accumulate all of the data about all of the ClickHouse clusters over there and EKS clusters. So we have all of the data with special labels in our Victoria metrics where we can further analyze it. And this is kind of how we achieved multi-cluster solution. OpenCost by itself doesn't support multi-cluster for cost management. It's the feature of enterprise KubeCost. And we use OpenCost, we are using OpenCost just like an exporter, because we do not utilize so far. I mean, we probably will be expanding that, but so far we just utilize the exporter, OpenCost exporter, which measures the costs and pricing for the current cluster, and then we just accumulate all of the data in Victoria metrics where we can query it for real-time monitoring. But we do it a little bit different. So in our observability stack that we run on Core EKS, which get the data from all of the tenants, hundreds of the clusters, and as well as about our control plane and Core EKS, then we push most of this data to ClickHouse, to our billing database. And also we get the data from each cloud about the spend cost. So we kind of have real-time data from OpenCost as well as the data about the actual cost from the cloud. And how we do that? So we just utilize ETL pipeline and push everything from the AWS core report, like we configured that to be on S3, GCP, BigQuery, we exporting this data to the GC for Google Cloud Object Storage, Azure for Blob, and we also need kind of real-time metrics as well. So we push some of the Victoria metrics from the database, from the time series database to the ClickHouse. So ClickHouse is kind of center of our billing. We upload all of the data about all of the tenant as well as our infrastructure in the ClickHouse, which is quite, the ClickHouse is quite suitable for that. It's actually was designed, it's actually designed for such kind of applications where you have ETL pipelines pushing all of the raw data, because all of this data in these reports, they have different format, schemas, and etc. We push it raw there, and then we just start to create with features of ClickHouse, we create different views, material views, and etc. to, first of all, show it on our Grafana dashboards, like what is the cost for this customer, for that customer, what a cost for our infrastructure, what's like the margin over there, and etc. etc. We get this all from ClickHouse through the Grafana, as well as we have a user UI which provide the information to the customer, like what is your current bill, what is your projections, what is your real-time spend. And it's also solved our solving our marketplace offering, because like the cloud cost, before this approach, cloud cost will come later, and cloud cost mostly suitable for monthly billing. So you kind of see the data later in the time. When with OpenCost and all of the monitoring data, we can bill customer per usage, like per hourly. So that's what we do, and this is really suitable for marketplaces. Like if you are listed on AWS, GCP, or other marketplaces, you probably need to submit that usage quite regularly. ClickHouse provides you really nice features. First of all, it's SQL, so you don't need anything else there. We we do all of the mathematics about the billing and all of the aggregation with these simple features. Like, first of all, we can upload data directly from S3, right? So we don't need, sometimes we even don't need the special ETL application to get this data to ClickHouse. We can just upload it from ClickHouse directly, reducing the number of development we need. Second of all, aggregating all of this data into something that could be used by application, UI, or Grafana. We use both material and as well as simple general views, which either store it on memory or just store it on disk. And aggregating it, we actually have usable information that has same format, right? That's like, this is a line item, this is compute cost, storage cost, object cost, etc., etc., etc. So all of that needs little application development, if at all. So most of it you can just do with the awesome ClickHouse features itself. Challenges. So all of this tech when we implemented it, and we kind of knew these challenges before, but they appeared to be more pronounced. First of all, network cost. Right now, open cost it's kind of support ingress and egress cost, but we do not use that. We use load balancer, our own proxy, and if you have a complicated network state, then you might have a problem with kind of define who ate those network resources. And it's not like you can, based on monitoring data, you can figure out which pod consumed what network resources. But the problem appears in the cloud that it could be cross-zonal, for example. And then you have interzonal traffic there, which you need to figure out who actually does that, who consumes this traffic in a big environment with a lot of connections, like client connection to ClickHouse, ClickHouse to Zookeeper. It's really challenging to figure out what those interzone traffic is and who is the consumer and how to optimize it. That's one of the challenges we found out. And another one is object storage. The ClickHouse can do backups of the data, customer data in S3 or cloud on object storage, and that is kind of not supported currently. So it's you cannot measure your object storage cost, and those could be quite extensive because it's backups, like terabytes of the backup data. Plus, additionally to that, it's not only the data or size, it's also API calls, how often you do that. And that's kind of a problem, especially for anomaly detection. If you have a lot of data and you forgot to delete your backup, you immediately see the bill increase, like petabytes of data. You forgot to actually delete it, and that's a problem. That's a problem where actually this cost management and analytics could help you, but not yet. There is a useful link. OpenCost is an awesome project. I learned a lot from Go code. They really nice. If you're curious about the monitoring, this is the way to go. And there is Altinity projects open source. It's a couple of them, Operator. And we also manage data source for Grafana plugin. It's also open source, and we use it extensively to visualize the data. Thank you. Any questions?
Thank you, Denis. We have a couple of questions. Let me bring them up. So the first question is, and let's see. You said that you run ClickHouse with Zookeeper. Why do you prefer Zookeeper over Keeper?
Yes, so ClickHouse has the Keeper project, and we currently adding the Keeper support to ClickHouse Operator. It was already a beta phase for it in the ClickHouse Operator. But so far, we haven't tested ClickHouse Keeper in good extent to graded to production. And also, I think in the future, like in the near future, we'll be switching to that, but new customers. And yes, this is a future for us, because like ClickHouse can drop Zookeeper support in any time, and Keeper is the way to go. It's a little bit simplified for this use case. So it's coming, but it's still not like a production grade for us.
Perfect. Another question is about, is this for Kubernetes workloads, or can I use it for all major clouds, or what can I use it with?
ClickHouse, so like it's for everything. It's like general real-time analytic database. Open cost you can use only for Kubernetes and clouds. So it imports your, like it shows your spans on Kubernetes for first and foremost, but also cloud resources as well. So ClickHouse, it's a general real-time analytic database, not general, but like data warehouse database. You can use it for everything. We just choose to run it in Kubernetes because it's easier for us, and we manage it there.
Perfect. What type of customer data are you backing up? At day 0, Kubernetes, what is your Kubernetes setup at day 1, including your customer workloads? So I guess it means that if you also back up the customer workloads at day 1, or the setup of the Kubernetes cluster itself, and what kind of tools are you using for that?
So we tried different infrastructure as a code solutions, like Ansible for GCP. Right now, using it a little bit, Terraform for everything, EKS and other resources. But we realized in time that we need to build our custom platform. So it's like a Go code written platform to provision any cloud resources. So it supports all of them. That's like our backend. It's our control plane that reconciles the infrastructure. And day 0, so we choose to use managed cluster. So we provision some managed cluster for you. If you are not bringing your own, you can bring your own. Then we just have a connection to your Kubernetes cluster. But we provision everything. We updated the cluster, the managed cluster. So it's still, you need to still roll those updates, etc. We manage node pools. We have autoscaler. So we do everything that you do not notice that you have Kubernetes inside. So you just have your ClickHouse database, and that's what and UI interface for it. Yeah.
Thanks. We have a little bit of time for last question. I think this was mentioned, but let's repeat it as well. So where and how do you store data from ClickHouse on Kubernetes? Yeah. And what do you use as your data storage?
Yeah, so I had a talk last year, I think, or no, early this year. I don't remember, about like how ClickHouse stores the data. We use GPT-3. Oh, sorry, GP3 volumes on EKS, or just regular volumes on GCP. ClickHouse is not so dependent on I/O, right? If you're hitting it with a lot of data, it even can read and write from the object storage. So, like from this perspective, like if we take EKS, we just store it on the in PVCs that we manage, and that's all. So it's just regular storage, and then we can resize those PVC, add more disks to the ClickHouse server, managing its configuration, etc., etc.
Perfect. That was our last question.
Okay.
Thank you very much.
Thank you, and feel free to approach me and ask more questions. Yeah, I will be around. Thank you.
And I will just remind, our next session is in 20 minutes. Welcome back, everyone. So next session is going to be how to run AI workloads on K3s cluster. It's going to be presented by Emrah from Prussia Research. It's yours.
Good day, everyone. I was going to say good morning, then it occurred to me that it's going to be noon soon. You might be getting hungry. I think there will be some break in an hour or so. Don't worry, next 30, 35 minutes, I will be the talking. And I'm going to cover basic concepts. Actually, I would like to start with one question. What is programming? Well, technically speaking, programming is giving set of instructions to the computer machine, tell to how to solve a task. So here we are defining every single step explicitly. So then what machine learning is? The machine learning, well, here, on contrary to traditional programming, we are not defining all the steps explicitly. On contrary, what we are doing, we are actually giving some data along with the output and expecting the computer to machine give us a program, which we call actually model. And later on, what we will do, we will give another data with a similar structure and then expect output. So, and how actually machine learning can do that? Well, machine learning is doing it using an algorithm or algorithms. And these algorithms actually are not anything new. And if you just look at a little bit the development in the AI field, that we will see even in 1950s, the key nearest neighbor was already there, so developed actually that year. And regression, for instance, is not anything new at all. It's used in the statistics. So then, why AI is booming now? Well, if we rewind the clock, go back in time, and look at how we used to deploy things, and come back today, look at the existing infrastructure, then we will see some significant change. In time, we become able to deploy large amount of data and process it. So basically, we have almost unlimited storage capacity and the process power, which help us to train better models. But that's not all. Time to time, in every single field, there is a revelation. There is something happens, which happened in AI field as well, that a transformer was introduced. This is usually used in deep learning. If I'm not mistaken, it should be natural language processing. It brought two innovations, big innovation, and it kind of changed the scope of the AI. So speaking of the processing unit, for instance, that the power we have, we can actually, these are not all, there are more units out there. I try to simplify. There could be one or two that you may know, you may not be see here, but my goal is here kind of show you, more or less the existing processing units. And we can actually categorize them under three distinct sections. For instance, general purpose. Well, we all know, right? CPU. We are using to solve daily basis tasks, such as this one, for example, I am presenting. And we can also have a CPU kind of categorized under different sections based on their instruction sets. And x60, x86, and the ARM is quite the one we are familiar, and RISC are also getting familiar. And the GPU, well, basically we use for the play games. But why? Because we need, and why we don't use CPU? A GPU is meant for the rendering, because there is a large amount of mathematical computation is required. That's why we use GPU. And in these days, there are specific GPUs for deep learning as well. So now we are entering a specialized area where we have TPUs. This is the one, the image you see is Coral Edge from Google. And it is quite simple, single board computer. And it can actually be used for image classification or object detection. And DPUs, well, these are basically kind of helper. They are actually taking some of the workload from CPU and do it in much secure and more efficient way. And the quantum computers, well, this is a new era for all of us, right? Now we are having more than 1,000 qubits. And mainly quantum computers is used for complex simulations, like if you want to do something with less molecules, and also cryptography. Well, I'm going to skip these two. So we have been talking about, yes, AI, workloads, AI, and how we can run it, processing units. So the question, though, what we're going to do with this? Like, we have the model. So our goal is not only training them, but being able to actually use them. So can we run these AI models on local, for instance? The answer will be yes. There is a very simple Python script that will load the model and then use it to predict. But if we can run models on local, can we run them on virtual machines? Well, answer will be yes. And if we can do it on virtual machines, can we run on containers? Yes. And now, if we can run on containers, if you already virtualize this model in an application on a container, will it be possible to run cluster? For sure. But then what cluster is? So basically, clusters are interconnected computers. In other words, they are joined machines, work together to support applications. What type of applications? Well, best example I can give you is the databases. Sometimes, not sometimes actually, you don't even realize that when you are using an application, whether you are reading data from another data source, or another, like a host, or another node, where the database is actually running there as a replica. Because one of the replicas, for example, might be crashed for some reason. Engineers might be doing something on that, like I did on my home lab 2 days ago, and I successfully crashed it. So you don't see actually something is happening over there. You are just getting still information. So basically, all machines are working together to support that application, and database is one of the example I can give it to you. And how we can actually create clusters. So one example will be, and one tool we can use is the K8s, Kubernetes. So it is actually well known. When I say well known, I mean it is like an industry standard, and it is kind of commonly used, but still it's kind of complex. It's easily, you can start with easily, but more you use, more you realize how much less you know. But it is a nice tool. I like to work with it as well, and I'm using on my home lab too. So it is actually kind of specialized way of creating a cluster. Mainly, you are using it to run containerized applications. But Kubernetes, K8s, in another way, it's for general purpose. And what if you want to run Kubernetes on ARM-based devices, like maybe at edge, maybe you want to do IoT? In that case, you can go another distribution called K3s. So this is a lightweight Kubernetes cluster, and you can basically run this on ARM-based devices. But how this actually cluster run a workload, or how we can run workloads on cluster? We can understand maybe now, we know now how we can create a cluster using different distributions of Kubernetes, but I think it will be better for me to talk about a little bit virtualization as well. So we have physical hardware at the bottom, right? And this could be even your local environment too. And there we are having the processing units like CPU or TPU or GPU, along with memory and the network card. Top of that, we have operation system. So we might run various different operation systems on the physical hardware. Could be Debian, could be, let's say, Arch Linux. And if we want to do virtualization, we may actually install applications like VirtualBox, VMware Fusion, or UTM. UTM is actually runs on Mac, and if you want to start the virtualization, do virtualization on Mac, like easy way, I will recommend you. It's easy to install, and it kind of seems doing good job. Also, VMware Fusion, now it's for free. You can also download it, and I think VirtualBox has always been free. So we can use these applications to virtualize on existing operation system. But there is another way to do that. The other way is actually not installing an operation system, but installing a hypervisor like Proxmox, for instance. So Proxmox basically access the underlying hardware directly. Applications like VirtualBox, for instance, they access the underlying hardware through the operation system. So on Proxmox, we can also create virtual machines as well as the containers. So if you want to create maybe a simple job, which will take maybe not that long to complete, you can actually create virtual machine using an automation tool. You can create a, let's say, a container using an automation tool, and then it will be, it will work, and then it will be terminated, for instance, and removed from the Proxmox. So I would like to look a little bit, actually, these applications things and kind of categorize them. So there are two, actually, hypervisors. Here we talk about the applications that you install on an operation system and or Proxmox. So they are actually called hypervisors, and there are two type hypervisors. One is type 1, which you install the bare metal. And one is, other one is type 2. It's also known hosted one. You install on existing operation system. Actually, there is a joke I like to, bare metal is the hardware itself. It's not like a rock band. So I would like to focus on type 1 hypervisors. And there are two I'm familiar with. There are two I run actually on ARM-based devices. One of them was VMware ESXi, which is gone now. Unfortunately, we are not able to download it. It was really nice. It has a really nice community, and people were writing custom scripts or even like drivers to run it on Raspberry Pi. It was running there for free, but now we are no longer able to install it. But Proxmox, on the other hand, can be installed on ARM-based devices in two different ways. One is Pimax. So I do not know now whether it supports latest version, Proxmox 8.17, but maybe you can upgrade it after you installed it. I haven't looked at. I focused on actually installing Proxmox as type 1 hypervisor on the Raspberry Pi directly. And I will go through each step and tell you a little bit more and also give you some tips. So it's actually quite straightforward, right? You need to start with the installation process. But let me tell you this one first. I am coming from a perspective that you have the Raspberry Pi, and you may have actually operation system installed over there, like the Raspberry Pi OS. Why? Because if you have the operation system installed, you can use the operation system to do some things. If you don't have it, don't worry. I will also some other slides to tell you how you can do it if you have the Raspberry Pi for the first time without any operation system on it. But if you have running the operation system, then you can basically install Raspberry Pi imager, or you can download it. I mean, you can install the imager using the package manager, or we can just download it. And after that, you can basically erase the SD card. And it must be SD card, not USB stick. For the first time when you are doing this, please be in mind, use an SD card. And after that, of course, everything will be wiped out, so be aware of that too. We are using the right SD card. So, again, you are on the Raspberry Pi OS, and what do? You update and upgrade the operation system, and you do full upgrade. I highlighted this one because it's kind of dangerous to do. It's not like should be your common practice you do all the time. But in this case, you can do it. And after that, you can install EEPROM package. You can RPA EEPROM via package manager, and then you can update it, and you can update the EEPROM. Why we do this? When we do this, now Raspberry Pi will be able to boot from USB. Because usually it just looks at the SD card, and that's all. Also, you can boot from the network as well. So after that, again, you're on the Raspberry Pi. You just need to run the Raspberry Pi config command, and then you access to, I'm not sure whether it is readable there. You need to go to Advanced Options, Boot Order, and select the USB. So what if you don't have the Raspberry Pi with an operation system on it and have another machine or something? Or what if you don't want to do any of these steps? So basically, you can actually use the Raspberry Pi imager on another machine, and you can choose to utilities images, and then choose the Raspberry Pi version. And after that, you can select the USB port, and then you will have the USB card ready. So you may not have any monitor to connect the USB Raspberry Pi, but if you put in the SD card, if you boot the Raspberry Pi, watch the lights. When you see green lights, it's blinking continuously. That means firmware is updated on the Raspberry Pi. Or you can just connect the monitor and see just a green screen. That means firmware is successfully updated. So this is what we are going to do here is required to access the BIOS, because we need to do two more things. So this script is a little bit actually over-engineered, so let me tell you what you will need to do. You just need to download the firmware and then copy all the files to same or another USB, but of course be sure that it's empty. And then download the UEFI firmware and copy all the files, the same USB, and there will be same files there, so you will overwrite them, and then delete all the files, start with kernel. So after that, you will reboot the Raspberry Pi, and now you will be able to access the BIOS. And as I said, we need to do two more things, and one of which is actually kind of funny. You need to actually disable the limitation for the RAM, because it comes with 3 GB limitation, and even though you have 8 GB, you won't be able to use the whole power. So first things, you need to do this one. And after that, so this might be a little confusing. We already actually choose the USB, right, to boot from. But You also need to tell the Raspberry Pi what USB port you need to boot from, because you need to use two USB ports. One is for the installation, and the second one for the storage. And you need to come to Boot Manager and specifically choose what USB you want Raspberry Pi to boot from. After that, you can actually download to Proxmox ISO, and the recent version I know, latest version I know is 8.1.7. And be aware you need to download the ARM version. And after that, you can use, if you are on Linux, you can use command line, or you can just use Balanacher to burn the ISO in a flash disk. So actually, you can do these steps maybe before and after, but when you reach here, now you have the UEFI SD card. We have already selected the USB to boot from. And remember, for now, we have some limitation. You won't be able to use Wi-Fi, so that's why you must internet cable connected, and you must have another storage connected as well, because Proxmox right away, when you see it, it will tell it cannot install. It will tell you this one. If there is no another storage, it can see, or if there is no internet connection. So, little tip, when installation is done, it will reboot, right? But because we have already chosen the USB boot and choose the installation disk, it will boot from that too, and then you will see Proxmox installation again. It's easy. When you see this screen, just click Escape, get the BIOS again, and then change the order, boot order. In fact, you don't need to even use the USB stick anymore, where you have installation files. You can just target the storage one, where the Proxmox has been installed. So, as soon as you access the dashboard, you might need to actually update the repositories, because you're going to use this for free, and you need to get updates. That's why you need to actually change the sources a little bit, but I will recommend you to just use the dashboard, and also this will be the first time you start using maybe the Proxmox, you will get familiar with. You just need to use the no subscription one, and that will be all. You will get updates. So there is one thing I would like to share with you guys. Proxmox has already a community, and there are lots of scripts out there, and you can actually access these websites, Proxmox scripts or helper scripts. So you just go through, and if you want to spend some time just going crazy with this, I am doing it, and you can actually learn more about not only the Proxmox, also what scripts out there and automation as well. One of which, for example, Home Assistance, and there is already a script for that you can install, you can get from there. It's just one line command. You will copy and paste the terminal on Proxmox, and you will install Home Assistance specifically on Proxmox on Raspberry Pi, or let's say ARM-based devices. In fact, if you look at the script, you will see how to create Home Assistant scripts. You will see how you create virtual machines on Proxmox. So here, I am using Debian No Cloud. If you are starting for the first time, and if you don't know what Linux distribution you should use, I will suggest you to use Debian, because it is to me, it is easy to start with, especially if you have the Raspberry Pi. There is a Raspberry Pi iOS may be installed, which is Debian version. So you are not going to actually, basically you are just enhancing the distribution a little bit, let's say. So upgrading a little bit. And then you can get familiar with the networking on Debian. You can understand how the Linux works, the containers, and later on you can move another specific Linux distribution if you think you have a reason, or just for fun, why not? And a couple tips. OS type is L26. It indicates the Linux. And I use SCSI single because it is the best practice. And BIOS type is OVMF. And here, two things more. Install guest agent. That will not work. For now, it's not working on ARM-based devices, or maybe on just Raspberry Pi. But I highlighted it because you can actually use it on x86 if you have it. And be aware that when you run command to add user, so now that user will be exist on the image file. So if you use it next time, if you run the script again, then you will get an error message because that user already been created, and you can use it again and again actually. And no cloud has no root password, so I am just adding my own root password. And this is the whole script how it looks like. And again, there is a small issue. We are not able to use actually cloud in it, unfortunately, which I really wanted to do. But maybe there is a bug. It will be fixed later. When you use IDE 2, for instance, and when you run the virtual machine, it says it cannot find IDE 1. So I am still figured out whether there is a solution for that. But this might work on, again, if you have a Proxmox on x86 machines. But this is not that sustainable, by the way, if you want to create this again and again and again. I mean, you can write a bash script, but it is not healthy. So let's get some tofu. As you may know, it's an open source project, and it actually can be used with Proxmox providers. There are 2 Proxmox providers I recommend to work with. Basically, what you can do, you can actually create a template, and after that, you can actually use one of these providers, clone it. So you can clone, for example, 8 machines, 8 times, and 3 will be for the control planes, and 5 will be for the agents, for instance. And after that, you can access those machines via SSH using an Ansible, and you can install the necessary scripts to run a Kubernetes cluster. And speaking of the scripts, so installing Key-Trace is very straightforward. You just need one line of code, and that will be all. But if you want to, create a highly available cluster, you can actually put a little bit more arguments. You can actually put different flags. I actually put there one, not label. I am going to explain a little bit more detail why I have done this. So as you can see, I am running one script on the control plane, on the host, that will be a control plane, and then that's it. It will be a control plane. And then I am getting the token, which is already generated, and then use this token to join that control plane, and then now we will have a one control plane, one agent cluster. But this is not what I want. I want actually high availability cluster. What I do, in the beginning, I just create HCD. So it will be just the HCD, and there will be no any scheduling. So I am disabling all other components, such as disable scheduler and API server. So if you have this installed, you won't be able to use kubectl, because I am... At the bottom, you see actually kubeconfig. I highlighted it. I actually don't use it because I don't want to access this machine and then access the cluster from that machine. I just want to be sure that HCT just up and running there. So I put it there, but I don't use it actually, and recommend you not to do that. Just you can check whether HCT is installed just using it is a service. So systemctl status key3s, and then you will see whether the service is up and running. So here bind address is the address of that machine. And now control plane. So keytrace URL, the first line, I am actually using the HCD IP address here. That's the HCD IP address. But if you look at the TSL, that is not the same IP address. This is the that is the load balancers or your proxy's IP address. So basically what will happen, later when agent want to connect or join this cluster, they are going to actually join via the load balancer IP address. So they will not know any control balance IP address. But control balance IP addresses must be maybe static or dynamic, but at least load balancers should know them. Then it will actually direct the traffic to control planes. So we already actually want to configure this, and we already disabled traffic, and we already disabled service load balancer. Instead, we're going to use MetalLB. So basically, you can create a namespace in advance. I do this because I want to have custom labels, which is kind of recommended, especially if you are looking for working with the pod security admission. And then you can, of course, you must have Helm installed. You can add the package, let's say, and then you install, actually you upgrade with install flag. Why I do like this way? I tried the other ways. The easiest way is just install. It didn't work. And after doing a little bit of research, it turned out that I need to wait for a validation failure policy. I need to ignore that. And basically, otherwise, when you run it, you will get error message that MetalLB cannot connect to the webhooks. So maybe it is just for the ARM-based devices. Maybe it will work differently on x86, but this is kind of the way I tried, and it worked. And you can also check the services later on. And the traffic, of course, after that, we will install. And there is, again, some configuration over there. I am actually upgrading with install flag. And one more thing, when you use Helm, when you are upgrading with install flag, I guess the Helm creates some instances. And if you install all the time, you create, I guess, new instance. And if you use upgrade with install flag, it upgrades the existing one. So you will have the same instance, I guess, about the versioning. So now we will have last part, kind of. We have 5 minutes to go, or? OK. 25 minutes we left already, 5 minutes to go. Okay, so let's say you want to add new node. So you can add 2 more nodes, right? Or any number of nodes you want. But here I want to show you how you can add actually a node as a Raspberry Pi or the Jetson Nano. where we're going to do AI workload running. So if you want to add Raspberry Pi as a node, there is a simple Ansible scripts over here. So the reason I am showing you this, if you want to run Kubernetes on Raspberry Pi, like you want to install the Key3s directly there, that's possible. After all, it is Linux. You need to do some little bit configuration. You need to basically enable the C groups. Otherwise, Key3s will not work. And this is a simple Ansible scripts. We'll do it for you. I mean, it's just the simple scripts. You can access the boot command line text on the operation system as well. But if you like to automate things, this could be one way to do that. So the difference is when you want to work with a node Jetson Nano, first of all, you need to install the Key3s first. So here, on Raspberry Pi, you are not installing the Key3s first. You are actually running the script, you do the change, and then you install the Key3s. Here, you must install the Key3s first, because then you will detect whether Key3s actually has automatically configure the containerd. And in other words, you need to see whether Key3s detected the NVIDIA runtimes. And you need to just check these 3-4 lines. And after that, you need to also make the NVIDIA runtime as default. So how we can do that? The best practice is do not do anything in the containerd configuration file. Just copy it with like some prefix, suffix, and then you can just change the default runtime to NVIDIA. After that, restart the containerd, restart the Key3s agent, and then check the status. So if everything went well, what we will do, we will test, of course, right? This is a very simple bash script. So basically, it's actually pull the image from the Docker Hub and then runs it. If this runs successfully, if the configuration is done properly, if the Key3 has detected everything, and then you will actually get basically an output tells pass, or you can check the logs and to see whether you are seeing actually this one. Pass. So this is the output actually. And you can do the same things using Kubernetes as well. We have installed it, right? This is the how we can run very basic, how we can create very basic part with the same image. And here, as you can see, I am pointing here. I guess you can see the cursor. The highlighted part is not selected, GPU CUDA. This is the label I actually have on the agent. And the reason is that when you run this part, it will be scheduled on that node, where actually we are having the CUDA. So Jetson Nano is our host or node, and then we are running this pod specifically there. And then when we actually check the logs of that pod, we will see some information, technical details, and after that we will see this result pass. This is the last message over there. So that's pretty much what it is. Thank you for listening, and if you have any questions, I have my coworkers over there. If I don't know, I will delegate them the questions.
Thank you. There are no questions. Are there any questions here in person? Let's give it 5 seconds, maybe. Ah, there is. Go ahead.
Was it worth the struggle?
So was it worth the struggle?
Yes. But I crashed it in my home lab, so there is no demo. I'm sorry.
How much time did you spend on it?
Like a month, sleepless nights.
Thanks for the question. Any other question? If not, thank you very much for your presentation. And we have 5 minutes for the next session.
Hello. Hello, everyone. Thank you very much for coming. Also, thank you, everyone that is joining online or watching live stream or recording. This talk is highly available Keycloak, highly available identity and access management with Keycloak in the cloud. My name is Michal. I am one of the Keycloak maintainers, and I work for Red Hat. I need to mention that a previous version of this talk was presented a few weeks ago by my colleagues, Alexander and Ryan, and I'm reusing some of their slides. So let's jump ahead and let's start. Like, what is identity and access management, and why do I need one? Basically, why do I need Keycloak? Well, I think you need one, or you should use it. Otherwise, I wouldn't be here. So how does it work then? So you have your services, an API somewhere running. It would be still the same. It's up here, down. And then you have your users that are joining or accessing the pages that you give them, basically. And if you use Keycloak, you then have a third service that is Keycloak running somewhere here. And what then needs to be done is that your users are authenticating against Keycloak as the first thing. So they share the credentials with Keycloak, so it can be username and password, but it can be also something else, depending on your use case. And then Keycloak provides tokens to users, and these users then can access these resources and send the token there. And the resources need to be then able to verify whether the token is valid or not. So they, again, talk to Keycloak and verify the token. And Keycloak then responds to them, OK, yes, I know this user. Their username is this, email is this, and so on and so on. You can configure what the token contains. And now, OK, so you have this setup, but what are the benefits? So first thing is that you need to authenticate only once per day. And this doesn't mean once per day for each application, but once per day overall across all the applications, because then the tokens can be distributed across all your applications, and all can verify that tokens are valid or not. This is called single sign-on, by the way. You can also integrate Keycloak with LDAP and Kerberos. You can also configure brokering to existing OIDC and SAML services. So this means these are these buttons, login with Facebook or Google, and this kind of stuff. And you can also integrate Keycloak with existing database. So if you have your users already stored somewhere, you can teach Keycloak how to communicate with this database. It requires a little bit of development, and you need then upload this piece of code as extension to Keycloak, but it works. So the basic login form looks like this. You have the username and password. This is all provided by Keycloak by default. And with a little bit of tuning, it can look like this. So you have the login with GitHub, Google, or whatever you configure. We have this documented. And then you fill username and passwords the same way as before if you are using LDAP, for example, because Keycloak then checks all the sources of users for you based, like it goes through all sources and choose the one that contains the user. And Keycloak also helps you eliminate some daily churn. So you don't need to do some housekeeping anymore because users can recover their passwords on their own. You don't need to like solve any tickets for that, or they don't need to create any ticketing systems. They can configure second-factor authentication themselves, and you can make it compulsory for each user, for example. They can self-register. So if you want to allow users to self-register, you can click a button in the admin console, and it will be available in the login screen. And they can manage their data on their own. So they can change also their emails. They can change their first name, last name, and so on. So then the login form would look like this. You see that there is a forgot password and register buttons. OK, that's nice. So maybe you created this setup. You are happy with that. However, Keycloak is now a critical component of your infrastructure. Here, I would like to share a funny story with you. So some time ago, when we were doing our regular bug triaging with my team, we came across this bug. And the reporter was complaining that Keycloak is not starting. And as an expected behavior, they feel that Keycloak should start with no excuses. And this was a little bit funny to read it that way in the ticket. However, This person is correct, because you are relying on Keycloak a lot, and you want it to be available 24/7. Like otherwise, if Keycloak is down, your services are not accessible. They cannot log in. The services cannot verify tokens, so they are probably pissed off. And that's why we started about a year ago a journey where we wanted to provide highly available Keycloak deployments. And this was quite a journey, and this started with something like that. So this was available even before. So you have n Keycloak pods, and you have, in each Keycloak pod, there is an InfiniSpan running. So InfiniSpan is something for storing data in memory. And then we have also persistent state, and the persistent state then contains data that are stored in database. So we use database for less frequently used objects, and InfiniSpan for frequently used objects like sessions. And this is to make sure that the data are accessed quickly, basically. So if you have more pods, you have then some clustering. You have the sessions are replicated across all Keycloak pods. This is done by InfiniSpan. And yeah, it's 2024, so you probably deploy this in Kubernetes, also depending, based on the conference we are at. And thanks to that, you are then able to tolerate a node pod failure. So this is already a highly available setup because you are resilient to a pod failure. However, there is still one problem with that, and it is that your Kubernetes workers are usually running in single availability zone. And like depending on your cloud provider, it can happen that the availability zone goes down as well. And therefore, we decided for our journey to tolerate availability zone failures. So the idea is simple. OK, let's have 2 Keycloak sites into availability zone. So let's say in availability zone 1, let's call it site 1. And in availability zone 2, there is a site 2. And the setup is the same as I showed you before. And this would solve the issue. However, this brings also a lot of new issues that we need to solve, right? Because we need to somehow maintain the state between sites. So for both the session state and the persistent state. To relax this setup a little bit, we decided to start with an active-passive setup. This means that one side is marked as active, the other is marked as passive. And then all the user requests are handled only by the active side. This simplification was really necessary for us in the beginning, because this greatly simplifies the write semantics. Because if you think about it, the flow of data is from users to active side of Keycloak, and then the data are then trickling down to the passive side down there. And as you would probably guess, in case of failure of the availability zone, we will redirect the users to the previously passive side. So for that, we needed to solve a few issues. So first issue is how to manage user connections, right? And for that, we chose to use AWS Route 53 load balancer. And the idea is like this. OK, so let's route all our users through Route 53. And then Route 53 determines which side is active and redirect all the users only to the active side. However, Route 53 needs to also know about when the site goes down. So it needs to have some health checks to Keycloak. So it's listening on Keycloak or periodically checking whether Keycloaks are up or down. And if Keycloak in active side is down, the switch is done, and the users are redirected to the site 2. One problem with that is that Route 53 is DNS load balancer. This means that the record in DNS is changed when the failure happens, and it can cause some problems if some clients are caching the DNS resolves, basically. So the failure can take some time, for a little bit more time for some clients that are doing the DNS caching. Another issue is the session failover, or the second issue that we need to solve was session failover. Now, this was the trickiest part, because remember, as I said, that these data are frequently accessed, and it is therefore read and write heavy. And for that, we chose InfiniSpan. So we were using InfiniSpan for a long time, and we were happy about it, so we also decided to use it in our highly available setup. I mentioned InfiniSpan already, but I didn't explain what it is. So what it is it's in-memory key-value cache store with advanced clustering capabilities. So what this means is that when we are storing something, a session data, a piece of session data in InfiniSpan, InfiniSpan ensures that this piece of data is stored in at least 2 keycloak nodes. And thanks to that, we are resilient to the pod failure, as I mentioned before. So we don't need to solve anything. We are just putting things to InfiniSpan, and it is ensured for us. They also provide a Kubernetes operator, and it is an open source project, of course. And it supports 2 modes. So one mode is embedded mode. That was the one that I mentioned before. So your InfiniSpan is running within your application, or it's sharing the same memory space and sharing the CPUs. But it also supports something called client-server mode. So this is then InfiniSpan is deployed separately in its own pods, and your application is running in its own pods. And they are communicating via some protocol. So they support Redis, HTTP, or their own hot rod protocol. So let's have a look how InfiniSpan can help us with solving the session failover. So the idea is, OK, let's have the InfiniSpan cluster spawned in each availability zone as well. And let's configure the cross-site replication support they have. So what cross-site replication does is that you can have 2 independent InfiniSpan clusters, but they are somehow connected between each other. So whenever you write something into InfiniSpan in one site, it is automatically written also to the second availability zone. And that's what we used. And also, we need to use synchronous replication. And the reason behind it is because Keycloak is a security product, and it is doing, for example, logouts and logins. And we need to make sure that, for example, during failover, if something is written to the side 1, we need to make sure that it is written also to side 2. So the users are creating something inside side 1, and Keycloak writes it to external InfiniSpan, and it's trickling down to the second InfiniSpan, and only then we are replying to user with a response. InfiniSpan also provides admin operations on the external InfiniSpan. And this is necessary for failover, during failover, because if side 1 goes down and you start it up again, the InfiniSpan and Keycloaks are empty. And you need to, because everything is stored in memory, so if you start it again, everything is empty. And you need to do a state transfer between each side. And only then you can redirect users back to the previously active site. And this is also possible using InfiniSpan. And as a side effect, the session data now survives Keycloak pods restarts. So this means that you can lose even all Keycloak nodes in both availability zones. But if InfiniSpan is up, the sessions are still there, and users do not need to log in again. So the third issue is database failover. So we need to ensure the same as for InfiniSpan for session data, also for the persistent data. And for that, we leveraged Aurora database from AWS. More specifically, it's Postgres flavor. And the idea is pretty similar to the previous one. So in the same availability zone as active Keycloak, we have an Aurora writer instance, which is then handling all the writes and reads. But we have also a reader instance in the site 2, or availability zone 2, that is then listening on all changes that are happening in the writer instance. And in case of failover, the writer instance, or the reader instance, is promoted to be new writer instance. And then all writes are going there. The failover takes around 1 minute, which is not which is not really a small amount of time, but it's better than waiting for all your Keycloak pods to start again. One disadvantage is that you need to have an AWS JDBC wrapper installed on your Keycloaks, because otherwise the failover takes a little longer. So when the failover happens, all Keycloak nodes need to drop their JDBC connections and use a new one to the new writer instance. And if the state somehow allows to keep the previous connections, it's bad because Keycloak cannot do anything, and it's just throwing exceptions. But apart from that, no additional Keycloak changes are required. So the whole architecture overview is like this. So we have the availability zone 1. We have our users going to Route 53, redirected to Keycloak, doing changes in InfiniSpan or Aurora database. The data are trickling down to the availability zone 2, to either Aurora DB or InfiniSpan. And in case of failover, we are switching the switch and redirecting all users to the previously passive site. Well, so that's it. That's the setup. And here are some things to share, some surprising system behavior that we encountered. So first thing is that we needed to enable load shedding. So previously, before that, what was happening is that Keycloak was queuing all the requests that were coming into one long queue. And if we were getting more requests than we are able to handle, this queue were like increasing a lot. And that was causing problems. So first of all, the clients were waiting for timeouts, or were waiting for their requests just to see timeout exception, some timeout. And the memory usage of Keycloak was increasing. So the remedy is, OK, let's drop the requests if the queue is full. So we have some maximum queue length, let's say 1,000. And if there is 1,000 requests in the queue, the 1,000 first will be dropped. So this helps Keycloak with less memory consumption, and also this helps users because they see quickly that the system is under load and they need to try again. Another issue was cache stampede. I'm not sure if you are familiar with that term. I was not before we encountered it. And the thing is that when you start a new Keycloak node, it has empty caches. So we are caching the calls to the database, so we are not going there so often. But if you start a new node, the caches are empty. And when the new node receives, let's say, 100 requests in 1 second, and we handle 20 requests at the same time in 20 threads, it can happen that all of the threads are going to the database for the same resource. Because what they do, they will check, OK, is this entry in cache? No, it's not. I'm going to the database. And if they are doing it concurrently, all of them can get missed in the cache. So the remedy was, OK, introduce some JVM level locking. So if one thread is going to the database for entry with this ID, let's wait for that request, not go to database as well. The third thing was blocking probes and metrics. So this was a little bit embarrassing in the beginning when we started, because like we are trying to be good Kubernetes citizens, and probes and metrics are probably something that you want to provide. But what was happening to us in the beginning was that during overload situation, during high load, our nodes or pods were sometimes restarted. And that's probably something you don't want to, because then other nodes will have a really hard time and restart probably too. And this was happening for a few reasons. So first thing was that we had blocking probes. So the probes were waiting for the database, or doing some request to the database and waiting for some operation to finish. And they were sharing the connections with other request processing as well. Another thing was that these requests were sometimes load shedded after we introduced the load shedding. And it were enqueued, or before load shedding, these requests were enqueued into same queue, which were causing timeouts. So the remedy was, OK, let's not block probes. Let's not enqueue them under overload situation and never load shed them. And the same for metrics. OK. During this journey, we had some good habits that really helped us being successful. So first thing is, OK, let's have up-to-date documentation during the whole journey. So we have a project called Keycloak Benchmark. And this Keycloak Benchmark contains all the details about the setup I just explained, described. And it has three main things. So first thing is, it contains documentation about how to deploy Keycloak in Kubernetes. Then how to create dataset in it. So if you want to do some performance testing, you probably don't want to have only one user and one client, one application. You want to create 100,000 users and do the testing. So this is, we have a dataset provider that you can use for that, and it is documented in this documentation. And it also helps you to run load on that. So you can check how to run load and how to see the results. We use ephemeral environments. So this means the idea is, OK, you can have as many environments as you want. However, you need to be prepared that you are losing these environments at the end of the day. So this helped us a lot because we didn't have any issues with some stale environments or some issues caused by long-running environments. And we were really happy about it. And third thing was measure, record, and repeat. You know how it is. You are doing 2 steps forward, 1 step back. So you need to be prepared for that. So we needed to add metrics collections and have searchable logs, because if some issue happens, we need to be able to quickly investigate the issue, so see the metrics, what's happening, and see Keycloak logs. We also needed to capture all insights after the run, because as I said, we are using the ephemeral environments, so we need to be able to capture all the metrics. We need to capture the results, because we need to be able to compare results from 1 month ago with today's results, for example, if something changes. And we also need to measure, do the measuring very often. So we have nightly runs for performance and functional tests. Well, this proved to be really useful a few weeks ago when Keycloak main changed the default hashing algorithm. And the default is now Argon 2, and Argon 2 has really high memory consumption, which completely broke our garbage collection. So we see a really huge performance drop, and we needed to solve it. If we wouldn't have these performance tests, we would probably release new Keycloak version, and only then we would do some performance tests, or there will be some users that are, well, not very happy about the performance of new release. And we would need to do the fix really quickly, while this way we were able to fix that before the release. Here are some tools that we were using. So, of course, Kubernetes. We are using OpenShift on AWS. We are deploying everything using GitHub Actions. So in Keycloak Benchmark, we have a lot of GitHub Actions workflows. So each of our team members can come to GitHub Action and create an environment for them. So they can say, OK, I want 2 environments in this region, in these two availability zones, and then deploy Keycloak with these settings there, and do a performance test on it and return me the results. So we were really happy about the GitHub Actions, how it worked. We are using Helm for templating, so you can quickly do some change. You can change some variable, some input to Helm, run Helm again, and everything is updated for you very simply. We are using Getlink for load running. We are using Grafana for displaying the metrics. And we are adding some additional instrumentation or some additional metrics via OpenTelemetry as well. So now this is what we have. This is already supported in Keycloak 24. It is supported also in 25. But what's the future about it? What we plan for future? So first thing, this is a little bit closer future, because this will be released in Keycloak 25 already as a preview feature, though. And it is persistent sessions. So if you are using Keycloak, you are probably familiar with the fact that if you restart all your Keycloak pods, you are losing sessions. However, with this feature enabled, the sessions are stored also in the database. And thanks to that, the sessions are persisted across restarts. That's the first thing. Another thing is that if we have the sessions in the database, we can then limit the number of sessions in memory, which means we have less memory consumption. And thanks to that, we have also better scaling. Well, the reason for that is that if you have, let's say, 20 million sessions in InfiniSpan across 6 of your pods, and you are adding a new one, you need to do a rebalancing on if new pod joins the cluster, you need to do some rebalancing, which can take some time. However, with this feature, we have the maximum number of sessions, 10,000, but you can change it just for caching purposes, and therefore the scaling is better. So if you are interested in that, here is a GitHub discussion that you can join. You can see how to enable this feature, how to run it. Well, you can test it and give us feedback. We would really appreciate it. It's a preview feature, but we would like to work hard on that to make it available for you in next release in full. Yep. By the way, this will be preview in Keycloak 25 that was not yet released, but it's just probably around the corner. Let's see how it goes. And now there is a little bit further future that we are still considering, and here are some ideas. So, okay, this was active-passive setup. So let's have a look at active-active, what we can do there. We have already some proof of concept. We have some steps that we want to evaluate and test, but we need to see what are the benefits of that, because maybe the benefits wouldn't overweigh the additional cost or the additional work we need to do. So we need to decide whether go this way or not. We can also simplify the deployments and the blueprints that we have in Keycloak benchmark document or in high availability documentation. We did some simplification already because in 23 it was preview. In 24 it is supported, so we did some simplification there. We did also some simplification from 24 to 25, so it will be released soon. Another thing that we can provide is adding support for additional cloud providers and databases. So far in Keycloak 25, it will be, or it is, only AWS and Aurora database. However, we can, maybe some companies or users have some legal requirements for, or they are used to using another cloud provider and other database. So maybe this is another way that we can have a look. And we are security products, so we can provide some security hardened blueprints as well. Here are some links. So here is the first one is the main Keycloak webpage, keycloak.org. You can find there also our main Keycloak repository. We have 20,000 stars. So if you want to add another one, we would really appreciate it. Then there is a Keycloak benchmark project. This is the documentation, so you can see all the 3 main pillars there. Then there is high availability guide, which contains all the building blocks about how to set up the deployment that I just explained, all the steps you need to do. We have Keycloak book. Now it's 2nd edition because we switched the environment from Valfly to Quarkus. So the 2nd edition is upgraded to contain information about Quarkus. And here is also the link for InfiniSpan. So you can go to their page and see whether you can maybe use it in your project as well, because we were really happy about how it works. Here are my contact information if you are interested to get in touch. You can also use CNCF Slack channel. Our team is available there. We have also some channels, so you can contact us. And here is a QR code for the slides if you are interested. Scan it, you can then find all the links there. And that's pretty much it from me. Do you have any questions?
Thank you. So we have a bunch of questions, so let's start.
So you can go to, for each client, you can configure some authorization. So you have resources there, and then you can configure some policies. And then your application can do some requests to Keycloak and check whether this user has access or not. And your application can then do this decision whether to show the resources or not.
Perfect. When do you expect that the Keycloak will stop releasing major versions so often to not break and to not have such breaking compatibilities?
Well, like this question is like twofold, right? Well, if we don't release that often, we cannot have the updates for you that often. I'm not sure this is currently on our radar to slow down, but yeah, not sure what else would I say.
We will see. Maybe next year. What about the master slowdown because of synchronization of the session writes? Is it a too big deal? Did you have a look at it?
Master slowdown?
Yeah, I guess the question is about the database, which had the persisted sessions and when it's syncing the data.
Yeah, okay, well, with persistent sessions, you are paying also, you are paying something for going to the database more often. So you will have more database usage, of course, that's expected. However, the benefits of lower memory usage and not losing sessions may be higher. It depends on your setup. So if you don't want to use persistent sessions, you can still keep the setup as we have now. But we will be working on the performance, so it is as performant as before. But yeah, at the moment, there is some penalty, of course.
So considering keylog is such a critical component as a part of your deployment, what are the best practices how you handle audit and admin events? What is the best practice there?
Mm-hmm. Yeah, so well, Keylog provides events out of the box. You can enable them in the admin console for each realm. And it is also possible to configure your custom event listeners. This means that you, again, do some development, you deploy something as an extension to Keylog, and then Keylog will send your events, for example, to Kafka or wherever you want them to be.
Is it the best practice to have a separate infinite span pods from the Keylog servers, or?
Well, we received already this question a few times. So the thing is that you are getting some value of having the external infinite span. The thing is that the main part is the admin operations that I mentioned. So you need to be able to, for example, push state, or during failover, you need to do some synchronization between sites, which wouldn't be that easy if we are using only Keylog infinite span. Yeah, it is somehow possible. There are some ways, some users are using it already. However, we decided to be on safe side and keep the external infinite span.
Perfect. Any guidelines on sizing the Kubernetes deployment, or maybe I will add, does your operator handle it?
Well, we have a sizing guide as part of the highly available documentation. There is a sizing guide that says, okay, if you have, so for all 150 logins per second at, I don't know, 3 CPUs in 3 node cluster or something like that, you can have a look at it. There is a link, so you can follow this sizing guide. And we will be updating this sizing guide based on the performance that we are receiving every day. That's what I mentioned.
Perfect. We have seen your plans for future development of the HA setup. Are there any significant features outside of that?
Yes, for sure. Yeah. We have a lot of improvements in authentication and protocols. So one team is working on that. We have OAuth SIG group, OAuth SIG. Well, that's the name for it. Sorry. So there is a OAuth SIG group that you can join their meetings and follow what are the newest changes in authentication protocol and what's happening in Keylog. So that's one thing. Well, we are always improving our UIs, so they are user-friendly, and so they adapt to new things. Well, recently we released something called user profile, which allows you to configure on your realm level. You can configure some requirements for user attributes, for example. So you can then say, okay, so each user needs to specify this address. And then they can go into their account console and fill that address, or it can be asked for, in registration form, and this kind of stuff.
Perfect. Maybe last question. So this is specific about the Route 53. Is it specific Keylog deployment? Can I use my own? And I guess the same goes for the database.
Well, these blueprints contains things that we are testing and that we support, basically. We say that this works for us. We are testing it every day. Of course, you can use your own load balancer or your own database, but this can bring this can bring issues. And then we wouldn't be that, if we don't have knowledge in something, we are not
you basically cannot
available.
support them,
yeah,
right?
We are not available for you that much as with these environments that we can, because if you report some issue with Aurora database, we can basically next day spawn this environment and test it based on your issue report. However, if there is some setup that we don't have, it would be hard for us to fix this issue for you, or harder.
Perfect. We are out of time, so thank you very much. We will answer the rest of the questions online. Yeah, thank you very much.
Thank you.
And enjoy your lunch. So welcome back, everyone. I hope the lounge was great and you enjoyed it, and I hope you will enjoy the session as well. So we have Maya Constantini here and Anderson Sasaki. They will be talking about bootstrapping and maintaining trust in the cloud with Keylime. I hope you enjoy it.
Thank you. So first of all, to introduce Keylime, let's try to see what problems does exactly Keylime solve. So we know that trusting remote machines that are not under direct physical control can sometimes be a significant challenge, and in particular in environments such as edge, IoT, or any cloud infrastructure that does often not belong to you directly. So our goal with Keylime is to protect sensitive workloads, even when they operate within less secure remote environments. So the question is, how can we be certain that devices in those environments run as intended? And how do we ensure a particular workload is not being executed on a compromised machine or virtual machine? So what is Keylime? So Keylime builds on existing hardware and Linux technologies that include TPM, TPM2 TSS, and IMA. It represents an evolution of integrity verification, and it enables remote monitoring of thousands of nodes. Keylime provides remote trust verification and covers measure boot and runtime integrity. So a bit of history about the project. It was started in 2016 with a research paper entitled Bootstrapping and Maintaining Trust in the Cloud that was published by the MIT Lincoln Labs along with a prototype. Then in 2018, a community was created around Keylime, which we can explore on GitHub under the Keylime organization. And by 2020, Keylime was accepted as a CNCF sandbox project.
Okay, so first let's go through some of the key technologies that we use in Keylime. So the first is the TPM, the Trusted Platform Module. What's it? Is a piece of hardware that is capable of performing crypto operations, like generating keys, signing data, and storing key. It is available everywhere, on laptops, on smartphones, on servers, everywhere, basically. What is so special about the TPM? It contains a key pair, called the endorsement key. This key pair is generated during manufacturing and is immutable, so you cannot take it out of the device or modify it. The manufacturer signs a certificate for that key pair, so we call it EK certificate, and they publish the CA certificate that signed it in somewhere public, so you can verify the identity of that TPM using the certificate. So since it's immutable, you have a unique identity for that device, for that TPM. So the point is that we don't trust the software directly, but we trust on the hardware root of trust, which is the TPM. The EK certificate has some limitations. It cannot sign data directly, but you can generate another key pair, which is called the AK key, the attestation key. It's associated with the EK in a way, so many Ks, right? But it's associated in a way that you can verify that something signed with the attestation key came from the TPM you expected. So another key feature of the TPM is that it has some special registers called Platform Configuration Registers, PCRs, that are designed to store measurements. So, and the TPM can generate a quote, which is basically the values stored in the PCRs signed by the AK certificate. So if you have the public key, you can verify the signature, and then you can verify that those measurements were legitimate. So how does the TPM store the measurements? It's through this operation called the PCR extension. So the PCRs can only be modified using this operation. And this operation is basically you replace the value of the PCR with the previous value concatenated with the new measure, and then you hash everything and put together back into the PCR. So basically it creates some structure similar to a Merkle tree, when the final value depends on all the values that were added before when you were measuring. So it can be seen as a summary of the history of all measurements that were used to extend that PCR. So if you have the log with all the measurements that you extend to a PCR, like a log, you can replay, like creating the extension and adding each measurement, and you have this final value that you can compare with something that you expected. And if it's the same, then you are sure that, those same steps were performed, the same extensions. So that's how you use the TPM to verify the integrity of stuff. This final value is also called reference value, or sometimes golden value.
So another concept that is important to understand if you want to understand keylime is measured boot. So what is measured boot? Sometimes TPM, actually TPMs are often associated with secure boots, as sometimes they were used by some companies to vendor lock the hardware by preventing it from booting another operating system than the one it was shipped with. However, TPMs have broader applications such as measured boot. So in measure boot, the kernel measures the BIOS EFI layer and extend those values into the TPM's PCR and the boot log. This process includes measuring boot images, OS arguments, firmware blobs, and more. It's important to note that measure boot is not the same as secure boots. Secure boot halts the boot if the process fails, but measure boot collects the measurements, makes them tamper-proof, and allows for a comparison of the PCR values with known good values. And you can also follow the boot log to reconstruct and validate those PCR values. The key difference here between secure boot and measure boot is that the secure boot can stop the boot process on failure, whereas the measure boot leaves you the freedom to take the appropriate action if there's some policy failure. So it's purely informational. Another concept is IMA, we haven't introduced yet. So IMA is the acronym for the Linux Integrity Measurement Architecture subsystem. It is responsible for calculating the hashes of files and programs before they are loaded. And it supports reporting on the hashes and validating if they adhere to a predefined list of values. So IMA was introduced in the Linux kernel in the version 2.6.30. It has 3 subsystems, which are called measure, appraise, and audit. The measurement component collects the hashes of files. That includes executable and libraries by hooking it to the kernel. The appraisal component compares a collected hash to a stored hash, and it can deny access if there's a mismatch between hashes. And finally, the audit component includes file hashes into the system audit logs, which can be used to augment the existing security system analytics and forensics. So when a TPM is present on the machine, the IMA measurement can be extended to the TPM PCR.
So what is file integrity? Is the file exactly what you expect it to be? So you can check the integrity of a file by comparing the hash, a cryptographic hash that you calculate over it with an expected value, or verifying the signature if it's signed. So this table is about what you can get by using only hashes or using signatures in IMA. You can see that each approach has different usages and assurances that it can provide. So for example, it is not possible to verify the origin of a file if you are using hashes alone. You need to have signatures so that you can check the origin of a file. So in the other column about signatures not being rollback proof is because once the file is signed, the signature is valid and trusted, while the key that signed it is still trusted. So for example, if a company releases a new version of a package that is signed, it doesn't invalidate the older version of the package. So if the previous version has some vulnerability, let's say, it's still trusted, right? Because the signature is still valid. So you can see that in this case, the rollback can be dangerous. In the hashing, on the other hand, you can, it is rollback proof because you will have to have the new values of the hashes, like the hashes of the new package will not match the old ones, so you will get the mismatch. About easy to set up, this is about the infrastructure that you need to sign artifacts and verify, so you have to deploy the certificates, have keys, etc. Whereas with hashes, you simply calculate the hashes and star as the expected value, and that's it, nothing else is needed. On the last column, about being update friendly, it's exactly kind of mirroring the problem with the signature, because if the files, if you are using signatures to verify the validity of the origin of stuff and the integrity of files, then it is easy to update because it will be signed by the same key you already trust, so you don't have to change anything. You, on an update case, you will simply sign the new package with the same key and it will be trusted. Whereas with the hashes, you would have to update the reference values with all the hashes of all files that were modified. So IMA signatures can be shipped by the OS vendors. It is included in Fedora since the version 36 and also in RHEL 9. Yeah, one detail about Keylime is that it can use both approaches. It can use an allow list, which is basically a list of files and their respective hashes, and also use a keyring of public keys to verify signatures. So you can mix and match these both approaches. Okay, so what is remote attestation? It is basically a mechanism to verify the integrity of remote systems. So you check that the remote system is in a state you expected. So if you have the log of all PCR extensions that were performed during the boot process, and you have all the measurements, the log of all measurements made to the files and extend into the PCR, and you have the PCR values, like signed by a TPM, so you have the TPM code. You can use the TPM public keys to verify that the code is valid, and then replay the logs and compare the final value with the signed value that you verify that is legitimate. And that's how you verify the integrity of a remote system. So you have reference values, you get the information you got from the monitored system, and calculate the operation, the cryptographic operation, the PCRs that you expected, and compare. If they match, then it is in the state you expected.
So now let's see a bit more about Keylime's architecture. So Keylime components can be divided into two main parts. The first part is the monitored host, and the second one is verifying components. The monitor host is the machine that provides its integrity to the rest of the Keylime system by generating and sending attestations. So this host machine must have access to some type of TPM, ideally a hardware TPM, but Keylime can also work with virtual or software TPM, such as in a virtual machine, for example. The monitor host runs a Keylime agent, and you could have thousands of those hosts, actually, but in this diagram, we chose to just illustrate one for simplicity. But it works with a very large number of nodes. The other components are responsible for verifying the state of the agent nodes and taking actions based on the verification results. So you have a component that's called the registrar that acts as a key store, and it tracks public keys that are also associated with the agent's unique identifiers, but it does not perform the verification itself. Instead, the verification is performed by the verifier. So the verifier checks the remote attestation that is sent by the agents and ensures that the attestation is signed by the appropriate TPM key, and that the measure boot state or the runtime state in the TPM quote. So a quote is a signed report of the current PCR values. matches the reference values that are specified by the measure boot policy and the IMA allo lists. The communication between the agent and the verifier or the registrar can occur over an untrusted network. And the verifier and the registrar, in this case, could be located in a different public cloud from the agent or on premises, and which creates a true hybrid cloud scenario. The network they communicate with can be untrusted because integrity checks are performed at each step of the process, and some pieces of information are encrypted with a public key that corresponds to one of the agent's TPM keys.
So let me explain the steps needed that Keylime perform, the workflow. So the first step is the registration. So the Keylime agent that is running in the monitored system will contact the registrar when it startups and sends the information about the identity of the TPM. So basically the certificate, the public key, and the registrar will associate both like the public key and the EK certificate together. Then the verifier will get the agent from the database that registrar stored and will ask for an initial code. So the agent will send an initial code, or called identity code, which is the code of the state, current state of the agent. The verifier will verify that that code is valid by using the public key that was provided in the first step. And upon a good verification, like when the state is attested, then the verifier can optionally release some payload and send to the agent. So after that, the verifier will periodically request a quote to the agent and verify the attestation. By default, is 2 seconds. And if one attestation fails, like in case of failure, then you can configure some action to be performed. For example, you could configure a webhook to notify or some script to run, and this notification can be sent also to the agent. So, of course, it doesn't target the affected agent because it's compromised. You don't care about it. But the other nodes may need to know something about the affected agent, affected system. So, and everything is configurable here. You can choose if you want to send some payload or not. If you want to check the measure boot, which is the state, the measurements made during the boot or during runtime or both. You can choose the allow list for the policies, like change the policy and expect different values. And you can, of course, configure the action that will happen in case of attestation failure.
So we can also secure Kubernetes clusters with Keylime. So let's see exactly how it can work. So deploying Keylime currently can be a bit of a tedious task. But however, recent efforts in the Keylime community aim to simplify this process by enabling Keylime deployments on Kubernetes or OpenShift. The Keylime attestation operator is a project that facilitates this easier deployment and also management of Keylime through Helm charts or a deployment based on operator SDK. This operator monitors nodes within the cluster where it is deployed, and it can also register nodes outside of the cluster in external and potentially less secure locations, such as, for example, edge nodes. So deploying Keylime in Kubernetes or OpenShift can offer some significant advantages for responding to attestation failures. For instance, if a worker node that is monitored by Keylime is identified as compromised, the revocation events can trigger Kubernetes commands, such as drain and cordon, and it can allow to quarantine the affected node from the rest of the cluster. This effort is still a work in progress, and contributions are encouraged. The long-term vision for the operator includes different things, such as making Keylime available in the operator hub, adapting it to specific OpenShift configurations, generating policies based on configurations, and also ensuring the state of the cluster is accessible to external services.
So I will talk a bit about another feature implemented in Keylime. So Keylime can attest the current state of the nodes, the monitored nodes, but it is in an online fashion. So how do you verify the state of like a previous state of a node? Or what if that node doesn't exist anymore, like if it's offline? So the way they figure out was implemented this durable attestation, which basically stores all measurements provided by the agent into some database. Here, the example is the record, the transparency log. It is important to be like publicly trusted, so it shouldn't be under the control of the person that controls the attestation infrastructure. So you push there the measurements you received from the agent, and then later in time you can recover that state at any point in time and verify that it is in a tested state. And you can even check that against different policies from the time the measurement was collected. For example, if you had some package with some vulnerability and you wanted to check in the past if some node had that package at that point in time, then this feature is what you need to verify that that state includes or not that affected package. So this provides make it auditable, the past states of the remote machines. So that's a superpower. You can not only have the attestation online at the moment you are measuring it, but also later in time, even when the node doesn't exist anymore, because you stored all the measurements.
So now let's take a look at Keylime's future, and in particular, the attestation of containers. So that's one exciting possibility, but unfortunately, currently, different obstacles prevent this feature from actually being implemented in Keylime. So a key challenge with attestation for containers is that files within containers can share paths with files in other containers and on the hosts, which is lacking segregation by container ownership in IMA. But also, each file's measurement is sent to the TPM, which can sometimes make it difficult to differentiate between them. However, some ongoing efforts may enable container attestation in the future, and this effort includes different things. So one of them is implementing IMA-aware namespaces in the kernel, but also supporting VTPMs directly in the kernel, so each container could be extended to its own virtual TPM, but also container IMA using eBPF. So this latter approach aims to extend IMA with namespace support without altering the host operating system, and it's doing this through a Linux security module hook, or LSM hook. These developments could pave the way for effective container attestation and enhance security in containerized environment as well. So if you want to find out more about Keylime, you can get in touch with us. You can visit the main Keylime webpage at keylime.dev, but also under the cncf.io website in Sandbox projects. You can find the different repositories under the Keylime organization on GitHub. And finally, you can chat with us on Slack under the CNCF IO Snack and the channel Keylime. Thank you.
Are there any questions? Let's check the pool.
Oh, clear. It was perfect. That's the information.
Okay, we have a question here. Can the remote attestation be integrated into authentication, authorization on an application level? for example, for various APIs, so that only verified node can use it?
And that's an interesting use case. Like currently, there is no such thing like associating the attestation with the authorization. So you can attest the node that it's in the state you needed, so you can be sure that everything that is running there is what you expect to be. That probably provides already the guarantees you need, but I'm not sure. Like, if you want to, for example, segregate or make only some APIs available depending on the attested state, then you would have to implement that separately. But yeah, so it's kind of out of scope for Keylime. It can provide the attestation, and then you can go from there and decide what is your policy.
Any other question? I have one. So where do you see cloud providers are going? Do you see them adopting or?
Sorry, once again?
Cloud providers, so like major AWS, Google.
Okay, so the major cloud providers are providing some TPM-enabled instances. So for example, on AWS, you can get Nitro-enabled instances that can use the TPM. So, and they are basically implement their own attestation mechanism. Each cloud provider is kind of trying to provide their separate attestation mechanism. So this is kind of the state. The current state is that there are many different fronts or different projects trying to provide the attestation, but basically there are some big challenges that affect everybody. One, for example, is the lack of the measurements. So the vendors don't distribute the reference values for the artifacts. So even Red Hat doesn't provide the reference values for the artifact. So it's difficult for you to create a policy beforehand. And so, for example, you want to restrict only, I don't know, artifacts from some provider to run on your system. So there's no way unless you create like manually, try to create a list of things that are provided by that provider. So it's difficult. So how I see is that many people are trying to provide attestation in many different ways, but it's all separate efforts. So.
Great, thank you very much. And I don't see any raised hands, so thank you very much for the presentation. It was great.
Thank you.
Hello, everybody. I hope you are ready to endure my shitty French accent for 35 minutes. Good luck. So my talk today, this is the first time I'm doing that talk, and I will also introduce to you a new tool. I will see later. I hope the demo will be fine. Let's cross the fingers and praise the gods of demos. So my talk today is how to dissect a malware by collecting its syscalls. I will explain what syscalls means. I don't really explain what malwares are. I think everybody knows. I will also explain what eBPF is, why it's a game changer. So, who am I? In French, Thomas Labarusias. Currently, I'm senior developer advocate at Sysdig, a Californian-based cybersecurity company. I'm senior developer advocate for DAME. I'm not managing the commercial product. I'm totally dedicated to the open source projects we developed. I was SRE for almost 10 years. I did 5 years of on-call. For example, I also did some FinOps because just to learn. I'm CNCF ambassador for almost a year now. Falco contributor, we'll see later what Falco is if you don't know the tool. Creator of tools for Falco. Beer geek, I drink a lot of beer, too much. And you can find me out on these social networks. So, on the other side, I'm not what we can call an hacker. I'm not an expert in malware analysis. I'm not white hat or even worse, black hat. So just to explain everything I will show to you now, you can reproduce it quite easily. You can understand quite easily what I will present, how it works, and what you can do with. You don't have to be an expert in kernel, in eBPF or else. Just for everybody, for example, for people that call them DevOps, what syscalls are. Syscalls are for system calls. Basically, when an application needs to get access to, for example, memory, to some CPU cycles, to the file system, or anything else, it will ask the kernel in Linux. Don't talk about Windows world, we don't care about that. But for Linux world, or Unix, each time an application needs something from a physical hardware, or not, or logical, it will ask the kernel the access. The kernel will say, okay, you have access, you don't have access. Wait a few milliseconds because someone else is dealing with that stuff, a mutex, for example. This, you can basically imagine the system calls as the API to access to the functions of the kernel. If you are familiar with this complicated stuff called the glibc, or if you are in the helping world muscle, you can consider them as SDK to manage the API, which is the system call. Oh, I have a clicker, I forgot that. In the last years, the kernel maintainers introduced eBPF for extended Berkeley packet filter. It comes from the BSD world, thanks to them. Basically, it's a way to introduce inside the kernel new features, new functionalities, without any modification of the kernel. It's live, it's dynamic. It comes with a lot of control, a lot of verifications to be sure we not create a mess in the kernel. It's really funny and nice to use. Right now it's used for security, Sysdig, Falco. It's also used for network, for example, Cilium. I saw the t-shirt. And diagnostic, a lot of stuff. So how it works, basically you write your program with Go, Rust. I think Python has also SDK. It will create an eBPF program. This program will be checked with a verifier by the kernel. It will be, to be sure you will not introduce memory leak, infinite loop, bad stuff. If the verifier agrees about your code, it will transpile them into bytecode for the kernel, and then the kernel will run in a little sandbox your piece of code. you can attach your eBPF, what we call a probe, to some hooks. Basically, each time the kernel needs to, for example, trigger a syscall or listen for a syscall, it will call your probe and do some stuff. This is how, for example, Cilium intercepts the network's packets to manage the routing, for example. And this is how sysdig or else are collecting the syscall to do what we'll see later. I think it's pretty clear now. Get an eye on ebpf.io to know more about eBPF. I will not explain that in a lot of details, but this is basically the main idea. How to analyze malware? We have two global methods. The first one is to do static analysis. But you get the binary, you open it in Vim, you change the mode for hexadecimal, and you try to see what's inside the binary. You can also try to decompile, uncompile the binary to get back the original code base, all this stuff. I'm not a security expert, or at least not for that part, so I will not do that. I prefer the dynamic analysis. Basically, the main idea is to, we have a malware, let's run it and see what's happening. It's not a new thing. I'm not introducing you a new method to do analysis of malwares, but I will present you maybe new tools for you to do so. We'll use, of course, eBPF. It's in my title. First, to do so, we'll use sysdig. I don't know if you know the company already, but it has been founded on top of that tool, also created by the company. Sysdig, you can consider that like a Swiss Army knife, including trace, TCP dump, htop, if a lot of different tools we may already use to do diagnostics or to analyze our systems. You can see that like we put all together into a single tool. This extract, this snippet is basically what we can get from sysdig from start without any more actions. If you are familiar with strace, it's basically the same pattern, but we can do much more. To use eBPF with sysdig, you have to just add this little flag. Why? Because sysdig has been created way before eBPF was introduced in the kernel. So by default, till now, sysdig will try to use a kernel module. We provide the kernel module, of course. But if you want to use eBPF, just add this flag. So we can add to our commands understandable and human understandable filters. It's a way to just capture a subset of the syscalls, not all of them, because so many things are happening in your systems at any time. It's easier to filter and focus, scope on only few syscalls. I think even if you're not familiar with syscall, if you never tried it, you are able to read the filters right now. I will focus on the container named, in that case, sandbox, on the Python program, and I will only consider input-output, basically read or write from a file, from a socket, network or Unix. And in that case, I will only consider file descriptors which are IPv4, so basically I will just consider network I/O. Easy to read, easy to understand. We can, basically with that command, you will see exactly what we had in that snippet. But sysdig introduces what we call chisels. Chisels are the way to basically format the output to get more, to get nice visualization of the syscalls. I will, for example, with the exact command before, if I'm scoped to the network I/O for the program Python, yes, inside the container named sandbox, and I use the chisel echo FDS, I can get that view quite easily. If you're familiar with TCP dump, you know we can collect the HTTP packets And then with a complicated command, we can have the input and output. With just that command, you can have the exact same in a much, much easier way. And we also provide a terminal user interface. If you want, if you're not really familiar with the filters and the chisels, you can use the TUI. I will try to show you SysDig in live. Cross fingers. Okay. Is that big enough or not? Oh yeah. So I will run this small Python server. I can curl it, pretty easy. And we'll try to get the output of this Python server like I did for the slide. So basically, I will curl my server, and I'm scoped on IPv4 on the container name Python, and I'm using that chisel to extract in real time the packets. It worked, nice. So from the Python perspective, we have the read. So basically, what the Python server received from my curl call. So we have the HTTP method, the host, user agent, my homemade header, the source IP, source port, and the destination IP, which is the IP of my container, and the port. And we also have the right for the headers and for the content of my beautiful HTML page. I can show you another example, much funnier if you want. I think you are also familiar with top, basically a way to monitor your system. So basically, I will run top every 1 second. And if you know how top works, basically it reads under /proc to get statistics. So basically, one line on that graph is 1 second. Each colored bar means we have events. Green means we have a few events. Red means we have a lot of events. In that situation, we see every 1 second, top will read from /proc, and you have these, we call that spectrogram. We can do so with almost anything. So for example, if you focused on DNS requests, you can use that graph to see visually if you have a lot of DNS requests or not. Another nice thing with SysDig is, like TCP dump, you can do capture. And you can apply the same chisel, the same filters, like we can do with TCP dump. Let's go back. To run my malwares, I will do that with a simple sandbox, because I don't know if you watch the movie with James Bond, I think. Basically, it runs malware directly in the lab. You see what I mean if you watch the movie. And I will not spoil, but I think you see what I mean. So we'll use a trashable sandbox. I'm pretty lazy, so I did it manually, but you can do that with Vagrant, Terraform, CDK, Pulumi, whatever. In my situation, I use the basic EC2 instance in Amazon, and I'm running two Docker containers in that EC2 instance. One for SysDig, one for the malware. We'll see why. And to be sure to not be a noisy neighbor, I also blocked all outbound connections to avoid the malware to try to replicate or to cause something else. Or if it's a botnet, or I don't know, I don't want to be a pain for the other. But you could just open, for example, DNS port. why I choose to use a VM and Docker. So for the VM, because it's deposable, easy to reproduce, easy control for the inbound, outbound conditions. I don't have to write any IP tables. Just with a security group in Amazon, it's easier. And for Docker, it's even more easy to trash them and reproduce them, and so. We have one level more of sandboxing, easy to switch from one OS to another. For example, if my malware was supposed to run in Red Hat environment, I can use a Red Hat image. If it's Ubuntu, I can use a Ubuntu image, and so on. Easy to install new packages in my Docker image or directly in the Docker container. And it's easier to install sysdig aside. And with that, because I have another level of sandboxing, I can just filter the syscalls concerning that container, including the malware and not the whole system. It allows to get smaller captures and at least with only suspicious events. How did I collect malwares? Just open anyone to internet and it's enough. But in that situation, my company ran an honeypot for a few weeks. You have the whole story there. I will provide to you the slides if you want. All links are clickable. So we ran a malware, an honeypot, and we were able to collect malwares. You can also try to search for them on GitHub. Some people are providing zoo of malwares on GitHub. You can use them if you want. So after a few days, we collected a few malwares. So I asked them to send them out to me. And how we will explore these captures. Maybe you don't know this guy. Well, basically, he pays my salary because he's my boss. He's Lois DeJourney. He's CTO and founder of sysdig. He was the original creator of sysdig and Falco. And he also co-created a small tool, maybe you know it, Wireshark. I think you know Wireshark. Pretty common in the network administrator world, and sysadmins too. It's a nice piece of software to basically explore a TCP dump, network packet capture. Wireshark is now part of sysdig. It's still a foundation, but it's part of sysdig more or less. And the developers of Wireshark are currently developing a fork of Wireshark called Logray. I don't know if the name is temporary or not, but let's call it Logray. This is a new version of Wireshark able to read sysdig captures, able to read syscall packet capture. And this is the first time someone will do a demo of that tool, so it might crash because it's still an alpha, and basically it might crash. So I did some captures. I ran some malwares they gave me, and I will not dig too much. It's not the topic today, but I will show you some classical patterns we can find inside malwares if it works. Sorry. Spoiler. So, big enough. I'm sorry, there is an issue with Qt. It doesn't want to change to light theme, so it will be in dark mode for now. I'm very sorry for that. So let's try the untitled. So we see a global capture, so it was really short, few minutes, 1 or 2 seconds of capture. All these syscalls happened. We have, for example, read writes. So this program called Untitled wrote a lot of stuff, read a lot of stuff from TCP, network TCP, but it's not really important. Basically, it just printed in the standard out hello world. I don't know why exactly, but if you notice that, it forked before to create a program called var Sophia. var Sophia is basically a crypto miner, I think. Basically, with just that, with the name of the processes, you can easily find out what malware it is, but this is not the part which is funny. This part is funny. After I ran that malware, it deleted itself. Unlink is syscall from the kernel to basically delete. It's not really a deletion, but to unleak a process. And you can see it deleted itself at the end. Classic to add your other capture. This one is funny too. Right. This one will add itself in the /etc/rc.local. So basically, to be sure it will run even after reboot, it had itself in the init in the list of process to init. Pretty classical. This is a crypto miner, for example. Another one, Sakura, not so much things to show in that one. We can see the DNS request. No success because all connections were blocked, but we can, if a process is trying to reach an external DNS for particular domains, for example, you can get that packet. Another one. Oh, this one is funny. Let's find read write. This one I knew before. It's a crypto miner. So basically, it will encrypt a whole folder. Then a message will be printed, will be created with that content, with a Tor onion address to reach the hackers, the hackers, to contact them, to pay, to encrypt, decrypt the files. The funny thing is, if you take a look about the network, no network activity from the malware. It means basically either they are lying, so they don't have any key to decrypt your files, either the same key is used to encrypt all files for all victims. So if we are able to find that key, we are able to decrypt all files for all victims. I'm not so sure, but and the name of this malware, you can search on Google after, is Conti. And maybe another one. Sucker. Don't remember which one I did, entitled. Oh, this one is not really interesting, but oh, demo effect, you see? Oh, better. We see the gym. Okay, I think I have an issue now. No, let's find another one. This is exactly what I did in my demo with sysdig, just to prove we can record a capture and read it with logray/wireshark, and you have all message. And if I follow the stream, you can see the exact same read and write we had in the terminal before. So we thought with sysdig, we can create easy to read, easy to reproduce captures. It's funny, you can do that on the fly, in your command line, in your terminal. But if you want something running in the background using the same filters, able to, for example, spot the encryptions, spot suspicious DNS requests, you can use Falco. Basically, Falco and sysdig share the same libraries, the same code base. Just Falco is a daemon to do that in the background. It's a graduated CNCF project, since a few months now, powered by eBPF2. So if you're able to run sysdig and write some filters for sysdig, you're able to write some rules for Falco. And you can also create a capture with sysdig, pass it to Falco to test your rules. I think I'm okay. If you have any question, I'm open to answer. I will provide to you the malwares if you want. If you want to repeat what I did, and if you want to reproduce with Logray, reach me. I will get you in touch with the developers because building that on Arch Linux was not so easy. Thanks.
Thank you. And we have a coffee break for 15 minutes. Enjoy. No question. And no question. If there is any question here, maybe? No question. Thank you.
So, can you hear me? All okay? Perfect. Hi, everybody. Welcome to this talk, Breaking Barriers, the Art of Free Gamified Security Training. Today, I'm here to share a case study that we didn't initiate. It came and found us, so that's a nice one to know. And I would like to start this session with a question. Who believes in the vision that software security should start from developers? Raise your hands if you share this vision. So pretty much everybody in the room. So this is about starting security from the beginning, not just shifting it along the way, because you know when you have security at the end, it's costly, it takes more time and so on. And now I want to do like a follow-up. Based on the security trainings you did in your careers, how satisfied are you with those? If you are very satisfied, like from 7 to 10, raise your hands. And if you feel that something should change in general, like 1 to 6, let us know. So, yeah, thank you. And this is the case and the opinion of many developers around the world. We asked our developers, you know, because GitHub is the platform where 100 million plus developers are building, scaling, and securing their software. And they told us that security training is less realistic outside of a dev environment because these developers were forced to kind of undergo video-based trainings that were full of theory and they were clicking the next button. And there are some other trainings that are similar to Who Wants to Be a Millionaire. They show you some software, some code, and they give you 4 options. And you have to choose 1 or 2 options, but in reality, in the real world, you can have dozens of options, and you have no guarantees that if you fix something, it's gonna be actually fixed. Many times, maybe most times, that when somebody tries to fix something, there are more problems that are introduced. Then there's lack of personalization when you have these video trainings, and at the end of the day, it's boring. So in the beginning of this talk, I told you about the case study that came and found us. Basically, we created an open source project. It's a form of a game. Some company used it, and then they said, oh, you know, we have something to tell you about our findings. And I want to introduce this company as a prop tech startup. Now somebody might think, what the hell is a property technology startup? So think about them as a company that is a software as a service, a centralized way to manage authentication and authorization in different buildings, agencies, and so on. For instance, the government of Czech Republic might have many buildings like this one. Instead of having authentication and authorization in each card differently, they can create groups and they can give to this building the same access as another building in a centralized manner. This company, at a point in time, and now we are before the game days, before the cool project we created, they started to use GitHub Advanced Security. This is how they were following our work. And for those that are not aware, GitHub Advanced Security is composed by a SAST solution called QL, a secret scanning solution, and Dependabot. And why I tell you this? Because this company had a scan, an initial scan, to find out their problems, their vulnerabilities. And they get this dashboard that is composed of secrets, vulnerabilities, dependencies. Dependencies is about supply chain. Vulnerabilities refers to software vulnerabilities. Secrets refers to tokens. And secrets are important because 49% of last year's breaches were because of secrets. And you know, these alerts can be low, medium, high, and critical. So when this scan took place, this company was looking like this. 180, the number is not important, but what is important is how this number is being separated. You see they have a lot of critical that they can get breached straight away. They have a lot of highs, some mediums, and some lows. And an important statistics to have in mind is that 60% of small companies that got breached in 2019 closed within 6 months. So it's important to understand the risk here, right? Okay, so they saw this. They start to take some action. Somebody can say, oh, nice, they do well. In just 3 months, they fixed 80 things. But look at the surface area. The red stayed as it was. The orange stayed as it was. The yellow halved. And the blue also halved. But the real problem is here. These kind of problems that were fixed are mainly fixed because of automation. Like dependable and secret scanning is low and medium, is straightforward, automated, and is driven by the security team, okay? This is not real progress. And it's not real progress because the chief information security officer, we are in a startup, it's important to remember that, had the vision that this company should have the developers fixing security issues. Security should start from developers, as we said in the beginning, and you agreed with me. So the vision was for them to be as resourceful. I don't like the word resourceful personally because we are humans, we are not resources, but you get the point. I'm trying to use his direct words, as the security team. And this is not what he wants. So at this stage, they started to use video trainings, they started to use office hours for security, and let's see what happened, right? So let's have a look. We are 5 months later. Wow, look at this, 18. Somebody's gonna say, wow, fantastic, they are doing amazing. Main drivers, okay, a SaaS solution, office hours, the alert nature was high and critical, complex and strategic. But the elephant in the room was exactly these office hours. Let's quantify in terms of the productivity of this company. It took them 2 hours in meetings every week. Initially, the meeting started to be 30 minutes, then 1 hour, immediately 2 hours, and then they were spending 4+ hours every week to fix issues. Because this, like you see here, is more strategic nature. They touch more on the design. It's more complex and more strategic. So in reality, this made the company unproductive, and the whole thing is unsustainable. Because we are in a startup, and this is the same for small, medium enterprises, even big enterprises, right? In security, you have to defend in every area. And you have to defend well, while the attacker needs to succeed just once in one area, and they can get lucky and do so, and they can achieve a lot. So this company was spending asymmetric effort in code security, and the rest of the company was not having the same attention. At the same time, this company expanded from 100 developers to 150 developers. They don't sound a lot of developers, but it's like 50% growth on developers only. And you know, when a company increases, you have more supply coming in, more supply chain risk. You have more humans in the business, and at the same time, you have more code lines. And as the code lines increase, the attack surface increase. So they were at a crossroads. Do we continue like we are? Right now, we have a low amount of bugs, and we can't keep up like this, or nobody in the future knows if we are going to have more or less. But if we keep spending the effort like this, the company remains as it is, unproductive. And they started to think outside of the box as they were following us in social media from GAS, GitHub Advanced Security. They saw this game, a game that I created in March 2023 from scratch to try and address every single developer problem, like video-based trainings, simulated environments, boring, and so on. Before I show you the game, the last thing I want to say about this company is that they wanted to give it a go. They brought all their developers together in Vancouver, Canada. It's a Canada-based company. And they mixed them in teams. Like they matched the junior developer with a senior developer, and they asked them to play the levels, to play the game, to see how it is and see if this approach is better. But what is this game? This game is called the QR Code Game. It's an initiative of my team, the GitHub Security Lab. I know I didn't tell you my name, where I come from, and so on. I'm going to tell you this at the end because I think it's more important to show you my work first. It's an initiative to provide in-repo learning experience where the developers, the learners, secure intentionally vulnerable code. It's an open source project, it's free, and in the same way this company used it, other companies, other schools, whatever universities that we are going to see in a bit have used it in the past. The updated numbers is 1.9 thousand stars and 5.1 thousand players, active players. Okay, so if you navigate to this repo here, in reality, we are going to be inside GitHub Skills. GitHub Skills is a free website that tries to teach skills for free, but practical skills, right? In the same way there is the Microsoft Learning and so on. Right now, I'm inside the skills. You can see at the top right, I'm inside the template repo, and I'm trying to copy this template so I can have a fresh version of it. If I click the buttons, I arrive at a stage that I can choose who is the owner, give any name, and I'm going to tell you in a bit the difference of public and private, apart from the visibility, of course, what else you are going to gain. After I created this template, after this new repo from a template repo, now you can see that it's in my profile, and I want to open this inside the code space. Why inside the code space? Of course, I can install everything locally, but inside the code space, I'm going to have a working version with everything installed behind the scenes in under 2 minutes, so that I don't have to make my machine full of dependencies and so on. And at the end of the day, you get 60 hours of free code space usage every month, so it's amazing. 60 hours are more than enough to play the game maybe 2 times. I believe you need around 15 hours to complete the whole game. So after this, let's see one more time the code space thing. So you click here from the repo, and you are in a code space. Code space is a virtual machine inside a browser. It looks like this when it's going to be opened after the code space. So this is my code editor inside the browser. It's synchronizing if I want to. If I log in with GitHub here, I can have my extensions, my tabs versus spaces, you name it, font sizes, the same as locally. And here on the left, I know it's a bit wide, I can't read everything. So on the left, you can see that there is, for example, season 1, level 1. Every season, there are 2 seasons. Every season has 5 levels, and these levels are of increasing difficulty. So level 5 is the most difficult of season 1, but once you go to season 2, level 1, the difficulty starts again to be easy. The first season has Python and C, because I coded that entirely. My skills are more on these languages. But the second season, because it was community contributed, has 2 levels in JavaScript, 1 level in Go, 1 level in GitHub Actions, and 1 level in Python. Every level has the same file structure. As you can see on the left, you have a code file. Let's open that. The code file has functional but vulnerable code. And we also provide you with unit tests that initially are passing. At the same time, we offer you a hack file that exploits the vulnerabilities in the code file. And initially, this hack file fails to show you that you failed to pass the level. You can go to the next level when both the unit tests and the hack file pass. You are given a hint, a model solution. Of course, there are more than 1 correct solutions. And you also have the chance to contribute following that guide at the end, like others did. Now, I told you there's some difference between public and private. The only difference is when you need more hints. If somebody wants to really try their knowledge in security, in my opinion, private or public doesn't matter. But if somebody feels at any stage, even if they started to be with a private one, they can use the public one so that they can use our GitHub Advanced Security for free. They can navigate in the security tab and see some alerts about some levels, and then after they see the alerts, they can try to fix the problems. If they push the code again and the alert is not there, it means that the code is secure, and they can go to the next level. Of course, they should also try the tests and the hack file passing. Back to this Canadian startup, the engineers had fun and a willingness to learn more because they saw the gaps. If we quantify this company was spending 15 minutes every 2 weeks in office hours for security instead of 2 hours in that meeting. And the developers were taking security for themselves. It was their job. Until now, the whole thing is sustainable, and this has become an onboarding training for the company without alert spikes. And again, this is free. You can fork it, remove the solutions at your own levels based on your own company's projects, classes, and so on. If we quantify these numbers, they started with 180 alerts, down to 7, and they were spending 4+ hours, and they are down to 15 minutes every 2 weeks. They ask their developers, how confident are you that you can take security in your hands? 9 out of 10 are happy enough to start doing it. And the company has SLOs, service level objectives, about the developers fixing the problems. Now, let's look at some universities that started to use our game. And it's in the same vein. They started using it, and then they are sending us an email, say how happy they are, and say thank you, send some photos, and so on. And the first university that started was the University of Novi Sad in Serbia. The technical faculty teaching teaching CS and distributed systems. So we have the professor, Erwin. He observed that it was more efficient like this because he was splitting the students in the same room, like here, for example, in teams of 5. They had to solve a problem themselves, and after they tried themselves, he was sitting here and doing the lecture. So they realized that's a better way to understand how things are done, and at the end of the day, he believes that this way he's going to have the next generation of developers that think and believe in their skin. They are true fans of that. That security should start from the developer and shouldn't come at the end because it's late and risky. Finally, I want to touch on why gamification works and the fact that it's everywhere. And this is because I kind of went blind into building something with gamification. I didn't realize that it's going to work. It was just an experiment. And then I realized that we are all victims, in quotes, of gamification. The whole market, first of all, tripled in size in just 4 years. 3.5 years. You see here from 9.1 billion to 30. But why? Some coffee shops, not the specific one here, for example, give you a stamp every time you take something from there. It's gamification. Social media with followers and likes is another form of gamification. When you get miles and points, when you are participating in small communities towards some goals, and when you are learning, for example, software security, there is a specific, let's say, amount of chapters you have to cover, and if they break it down like these with the rewards and stuff, they make it easier. Okay, but what does it make it to work? What it makes it to work is the real and powerful emotions. The ones of happiness, intrigue, dopamine, and excitement that come from these things. We think that we have control. For example, I don't know if you are fans of GTA, the Rockstar game, number 6 is gonna come out, yeah, okay. We are like driving some cars and whatever inside something, and we feel free and we can go everywhere. In reality, you are free inside a map, inside a predefined area, right? So we feel that we have control and we are masters of our own destiny. There's a known reward and paved way, so we know that after we do this, we are gonna win that. It reinforces good behavior. Back to social media. To get likes and follows, you have to post. So you continue doing so. And if we speak about the leaderboards, Social media with millions of users don't really use leaderboards because they are gonna make people to not have incentives or who is the person with the most likes, most followers. And to go against that, they create smaller communities of people, like in Strava and other athletic ones, you have smaller communities against that. A sense of achievement, you did something, competition, escape and explore, teamwork and collaboration, which is a big one with the secure code game. I summarized all here in case you have to understand why gamification works. Back to the secure code game, final slides. Our game is open source, is community driven, developer first, customizable, hands-on, and gamified against every single statement that you see here. And our community and players prove that is like this. So I invite you to not miss the chance to try out your security skills. If you so want to, you can check out Code Security for free. If you have a GitHub Copilot license, you can also try that. I have a talk that is purely on Copilot for security, but I post a lot of these things on my LinkedIn as well, and you can try things out if you want to. My advice is not to, if you want to learn. And finally, Code Spaces, with which you get 60 hours of free usage every month. Again, we welcome your contributions, like Denise. Denise, who works for HashiCorp as a senior product security specialist, put a lot of the problem he sees in real life into the game. He authored 3 of the 5 levels of the other season, of the second season, so that he could have a real impact in the real world of security, because he knows that with myself and my team, he can achieve so. My name is Joseph. You can ask me anything around this conference here or online at JKCSO on Twitter, and my name is Joseph Katsioludis on LinkedIn. I love to create content for developers because security people don't really know how to speak to developers. They have a language that is like, this is how I'm going to hack you, and I'm going to get this data like this and like that. No, we should speak in a way that is developer first. I'm coming from the GitHub Security Lab, which is a team of security specialists that try to secure the open source software. And we are all depending on that open source software, either directly or indirectly, because your phones, your fridges, whatever, your cars are using open source software either directly or indirectly. And if we quantify our impact, in the past 4 years, we found and helped fix more than 1,000 security issues, 600 plus of which have been given security identifiers. So if you want to keep up with us, you can find us on Twitter, on X, formerly Twitter, at GH Security Lab. We post the latest research we have and some developer-first content from me. So thanks a lot. I'm here for your questions that I forgot to remind you that you could ask from here, but you can also ask from here, like you can shout something. If you want to ask something later, you can find me around. You have been a fantastic audience. I know the energy is a bit low after lunch. I feel the same, but when you have energy boosts, I'm here for you. Thanks a lot. Any questions? It either means I explain everything very well and all is understood, or it's like I don't bother asking this guy what the yeah. So cool. Thanks again, and you can find me outside. Is anything from here?
No,
okay.
Unfortunately.
It's what it is.
Thank you.
Thanks a lot.
Hi, hello everyone. Good afternoon after the whole day of the conference. I guess you already ingested quite a lot of interesting knowledge, so thank you so much for showing up here at the end of the day. My name is Tomasz Tarczyński. I work at Isovalent. My role there is a customer reliability engineer. So what I do as my day job is basically helping customers running Cilium in production, making sure that they have their experience is that Cilium runs as reliably as possible. So what I want to talk today is day 2 operations for Kubernetes networking and how to do that with Cilium. Let's get started. So first, you might have an experience like that, working with Kubernetes, deploying stuff on Kubernetes, being happy that it all works, but then raise your hand if you ever felt like this, trying to learn about Kubernetes networking, seeing how much complexities is there. I mean, myself, it took me years and years to get at least some reasonable understanding of how it works, and there is for sure still a lot more that I still don't have a really deep understanding. So we will start with introducing Kubernetes networking, just very, very briefly, then talk a little bit about what I mean by day 2 operations, then thinking about Cilium networking, Kubernetes networking in general, but then with the Cilium focus as well. What are the important design decisions? And the last bit would be about observability. So let's get started. Thinking about Kubernetes networking, I wanted to start, take even one step back and start with how traditional networking looked like. So back in those old days, you tended to run your applications statically on a given node, then you gave them static IP addresses, you assigned those to the nodes. The routing protocols, you might have dynamic routing protocols, but it still didn't change a lot. And then what are the important networking topics that you needed to take care of when running distributed systems? So one thing is connectivity in the east-west direction, so between different applications within your data center. You needed to have some way of service discovery. A very simple approach would be just a DNS server. There are more advanced options as well, but let's keep it simple. And then the north-south connectivity. So it goes both ways. Your applications might want to connect to the outside world, and similarly, your end users would connect from the internet to your application. So you need to plan for that. For example, with stuff like layer 7 load balancers or a reverse proxy. And of course, you want to make this network secure. For that, you would use stuff like firewalls. You might do encryption of all the traffic, even inside your data center. And then you might require your applications to authenticate to each other and to get authorized to access each other. So that's my just 2-minute intro to how traditional networks look like. Was it simple? You might think that it's simple, but that's my teammate, Piotr. So he's doing this stuff for 20 years, and that's his bookshelf of his networking books. So if you go deeper and deeper into those topics, even traditional networking, it's, I would argue, not an easy thing to grasp. And now let's enter Kubernetes. So our cloud native world. Topics are the same, but we approach them slightly different. And I would argue the very most important difference here is that everything now tends to be really, really dynamic. So we run our applications in pods. Where they exactly run, we don't really care so much because it's all dynamic. So somewhere on those hosts, but we don't know anymore where exactly. They do have IP addresses, one per pod, but it also happens automatically, dynamically for us. Thus, routing connectivity between those applications, it needs to happen dynamically as well. Of course, it's not just magic everything, like those packets needs to get from point A to point B somehow. So you can still see this underlying network below our Kubernetes cloud, so it still needs to connect somehow. And then the topics I mentioned before, they still apply here. So applications are connecting between each other. For that, for east-west connectivity, we typically use services. So that's Kubernetes abstraction for connecting applications. But we might also go a little bit more advanced, do stuff like service mesh or gateway API, also for that. We need service discovery. We have the DNS service within the cluster. And we also need this north-south connectivity. For that, we typically use either the load balancer type of a service or stuff like ingress or gateway API to control not only traffic on layer 4, but also to have layer 7 controls over the traffic going to the cluster. And we also do have our security needs. So we want to limit which application can talk to which one. So we use network policies for that. We might want to encrypt our traffic with transparent encryption. And we might want to require our applications to authenticate to each other. I've also put where those things can be done in different components in our cluster. Let's see a summary of that. So we have different components different networking components in Kubernetes, and what their roles are, just those things that I've just talked about. So CNI would be responsible for IP address management, routing, and also security. And then we've got kube proxy for the services, DNS for service discovery, ingress for north-south connectivity, and then stuff like gateway API addressing similar needs to ingress, and service mesh to have even more fine-grained control over all of our traffic. So when I think about Kubernetes networking, that's pretty much the landscape that I have in mind. Let's then dive into the day-to operations. Because from my experience when working with customers, the users who run this in production, they really, really care about those considerations, like how to make sure we are successful for the long term. To start with, who has ever seen this quite an old thing, the 8 fallacies of distributed computing? That's something that came from Sun Microsystems 30 years ago. So they were trying to reason about what are the important characteristics of distributed systems. And they observed that engineers pretty much invariably make those false assumptions. And the assumptions are, number one, that the network is reliable. People tend to assume that. Stuff like latency is 0 and bandwidth is infinite. Basically, if we run network distributed systems long enough, we then learn the hard way that all of those are false. They are all not true. Going further, people assume that the network is secure by itself, that the topology is static, it doesn't change. There is one administrator. That's one of my favorites, because it assumes that there is just one person who makes all the decisions about this network, which is typically not the truth. You would have multiple teams designing and running those things. And then transport cost is 0. In the cloud, yeah, you can learn this, that it's not true the hard way as well. And the network is homogeneous, so it assumes all the segments of your network would behave exactly the same, which you can learn it's also very often not true, or typically not true. Okay, so what considerations would I recommend to keep in mind when planning for your, let's say, production Kubernetes story, how to design your network, what decisions to make? So first one, reliability. It cares about stuff like defining your service level objectives. How would you measure what does it mean that the things you run, that it runs well? Stuff like availability of your components, which might be not such easy to define like in fine-grained manner. Performance, what are your performance expectations? So those things that we just talked about, like latency, throughput, stuff like that. What are the typical failure modes? So how your components can break. They will invariably break sooner or later, but that's good to think about it in advance. What happens, let's say, what happens if your Kubernetes API goes down? It's not available. How it affects all of your networking components, and what functionality will be broken there, what would still work. And then troubleshooting tools. With traditional networking, you had your TCP dump, you had your observability there, and things were quite straightforward, let's say, or way more straightforward. And now it's way more difficult. Looking at a TCP dump in Wireshark, it doesn't help you much, because those IP addresses don't make much sense. Like, you can't easily know which IP is what application. And then planning for long-term maintenance. So what kind of support you need for all those components for your network? Are you supported by your cloud provider? Does it include each and every component there? Or do you use third-party components? And then what kind of support you need? Or like, are you happy with just being supported with the open source community, or you want something more? How would you plan for upgrades and the possible deprecations? Like, some functionalities might be discontinued, or even some projects might be discontinued. Probably difficult to plan for that, but something to keep in mind that might happen as well. Thinking about performance and scalability, it's mostly like the two factors I already talked about. Then trying to plan, like, are you well prepared to run at the scale that you need? There is Kubernetes 6 scalability that discusses those topics. One of my colleagues at Isovalent is leading that 6 scalability, and one of the things they do is they define the service level objectives for Kubernetes. There are many different parameters there, but among them there are the networking params as well. So they ask questions like, what is the latency in your network for programming it? So when you add a new application, a new pod, how much time it takes for your whole cluster to converge to be able to route traffic to that pod. What is the ping latency? So just sending a request from one pod to another. And similarly, for kubedns, the same thing. How much time does it take to program it when you change definitions of your services? And how much time it takes to do a lookup. Those things are among the topics that we see that the Cilium end users care about a lot. And when things go wrong, it's something they really want to troubleshoot. And yeah, that gets really, really important. Like you would probably don't think about it when everything goes smoothly, but those things are, yeah, sometimes fragile as well. Security. So the first layer of security in Kubernetes, that's network policies. They are identity-based, so you no longer define your firewall rules by IP addresses, but you rather want to define which pod, which workload can talk to which other workload based on labels. And those can be defined on layer 4 or as well on layer 7. That depends to like what exact decisions you make, what components you choose. You might also want other things. You might want to do transparent encryption, to do mutual authentication, or even zero trust networking when application will not answer the request unless it's all encrypted, authenticated, and authorized. Yeah, and you can achieve those things with different components in your cluster. Observability, yet another day 2 topic. And I would argue that I view this one as probably the most important for the data operations and for your long-term reliability story. Because if you can't observe something, it's really difficult to reason about how well or how bad it runs. And yeah, the Kubernetes networking model, it changed quite a lot for networking observability. The typical questions here are, how can you observe your network flows? I mean, not only seeing a graph, how many requests have hit the application, but actually being able to see each individual request going through the network and being able to follow it. Then there are network policies, and you would like to have some visibility for that as well, also in form of graphs, but also in form of flow logs. And also here, it's observing the health of your components in your network. So saying visibility, I mean logs, metrics, alerts, and tracing. All those things are really important to think about when planning that. And the last part, the human factors. So that's also important not to forget. And especially, I would focus on the first 2. So we saw the whole landscape of the Kubernetes network. There are quite a lot of different things, and there can be quite much complexity in it. Depending on how exactly you implement it, it can get complex and can get quite overwhelming for people running it and people using it. So that's also something important, to think about the cognitive load of people working with those systems. And other stuff, it's like, for example, cross-team communication. There might be multiple teams dealing with your cluster or even operating it. Also thinking about human error as well. Okay, let's now jump straight into the design decisions that I would say are really important to make when planning for your production setup with Kubernetes network. So we talked about how the networking model looks like. And now building on top of that, I would like to focus on one of the components, the CNI. CNI, it's the container network interface. So that's a standard API defined by Kubernetes. It deals mostly with two important topics. One topic is that each pod in Kubernetes should have its network configured and IP address assigned. Let me jump here. So CNI takes care of that. It assigns IP addresses to pods. And then the role of the CNI is also to make sure that connectivity works between those pods. How this is implemented? It's done by the CNI plugins. You can choose among those. And they take care, apart from the IP address management, also about routing. So how this connectivity is actually implemented. We will look into that a bit more in a moment. So when you're choosing your CNI, there are quite a number of different options. And yeah, I would say for quite some time it was not an easy decision to make. Like when you studied for your CKA, you saw Flannel and Calico there as two options. One of them had network policies support and the other doesn't. But how it looks like today, I will not talk in detail about the different CNI plugins. Also, obviously, I wouldn't be objective discussing that, as I know one in very detail and others not so much. So just the information from the CNCF landscape. Those are the 6 most popular options, and people tend to choose between those. But also, if you run your cluster in public cloud, then your public cloud provider, they made some decisions for you already. So you set up EKS cluster, there's already Amazon VPC CNI. In GCP, you have the new option powered by Cilium, but also the legacy option powered by Calico. And similarly, in Azure, the newest option that they have is powered by Cilium, but they also have their own older Azure CNI with optional Calico network policy support. And those providers, they also let you choose your own CNI. It differs from one to another. So for example, AWS, they specifically list the 4 Amazon partners who they also recommend that you can choose between. In Azure, you have an option to bring your own CNI setup and then configure whatever you choose. Okay, so that was about like the options you have, but now what's the architecture when you decide to run Cilium for your Kubernetes network? Very, very briefly, because it's not the topic of this talk. So what's important is that Cilium CNI runs on each and every node in your cluster, and it uses eBPF, which means it can program the Linux kernel to run all the networking logic there with identity-aware routing, with network policies and all the Cilium features, without going through the traditional Linux networking stack, which gives you really, really vast performance benefits. Yeah, that's a comparison between the traditional implementation with IP tables and Cilium implementation with eBPF. And yeah, with IP tables, the implementation of stuff like services, it required linear scaling, going linearly through the list of IP table rules in the table, while eBPF implementation, it uses hash tables for fast lookups and yeah, mapping your identities to the detailed networking rules. That's how Cilium runs, how it works. So the agent needs to talk to kubeAPI server. It watches a bunch of different resources there, and based on that, it programs your Linux kernel to basically program those networking rules in the kernel. Okay, so designing how to run Cilium, what are the decisions you would be making? First one is about what type of routing you want to use. And that two high-level options. First is encapsulated routing. So to make connections in between nodes, and those nodes might live in different network segments, Cilium would create VXLAN tunnels between each and every node. It basically encapsulates your network packets in UDP packets. What are the advantages of that? It's a really simple approach, like it will run practically everywhere. The only requirement is that you need to have UDP port or 8472 open on those nodes on firewalls, and that's it. It gives you possibility to have really large address space for your pods. It's configured automatically, the default mode in Cilium. It also has a disadvantage, so it adds an overhead for your MTU. So this encapsulation will eat 50 bytes of your network packets. And then there is the other option, which is native routing. So here we are using the underlying network to take care of routing in between pods in your cluster. To make that work, what needs to happen, we need to configure the routing tables on all the nodes so that the nodes are aware how to route traffic to pods on all other nodes. And similarly, the underlying network also needs to have the knowledge of this network topology and how to route. What are the advantages? There's no MTU overhead anymore. You don't need to do source network address translation when going outside of the cluster. Your performance could be a little bit better. And there is a disadvantage. So the most important is that there are those requirements for the underlying network. Plus, and because of that, the underlying network requirements, it might get more difficult to set up. And the second very important design decision, it's about IP address management. So there are multiple different modes, different options for that. I will not go through them in detail, but that's something you definitely would need to plan for. In most cases, I would say the approach I would propose would to be go with the default mode, so cluster scope, which enables you to run either encapsulated routing or native routing. But there is a caveat to that. If you run in one of the cloud providers a managed cluster, then I would say it's way better to choose one of their IPAM provided by those cloud providers. And each of them has their own thing, and you would run native routing then. Okay, so to end with, as we are running out of time, so yeah, just to take a very short look into the whole networking landscape in the cloud native CNCF landscape. So we talked about all those needs in terms of networking, and just looking briefly how we can implement each of those. For the CNI, you can choose to use Cilium for that. Then you have this east-west, north-south connectivity implemented typically by kubeproxy, but there is an option to replace that by Cilium as well. If you need an ingress controller, Cilium can cover that too. Similarly for Gateway API, and similarly for most of those service mesh functionalities. But a caveat to that would be I wouldn't recommend to start with everything just at once. Thinking about the typical journey of people implementing those different topics, those different needs, I would argue that perhaps a better, more sensible approach would be to start here. So if you can, you always need to choose a CNI. So I would say put Cilium there, and then I would say the second topic would be to focus on observability. Okay, as we are running out of time, I will not go through the observability demo that I had here. So apologies for that. If you want, you can catch me here during the conference. I can still show you what I have prepared there. And what I would recommend instead is you can play yourself with all those things. So we have a really vast library of Cilium labs where you can learn all those functionalities in hands mode style, especially those related to observability, so the golden signals with Hubble and flow visibility with Hubble. And that's it. So thank you very much for listening. Do we have any time for questions?
We have 1 minute, so is there any question? And I would say no, so thank you very much.
Thank you all.
Hello, everyone. Thank you for joining me. Really glad to be here at Kubernetes Community Days Czech and Slovak, and for surviving so far. So good way to go for you as well. And on this session, I'm going to talk to you about a very hot topic, about platform engineering. And specifically, I'm going to look into what it is behind the hype and whether it's something new altogether, whether it's just a fancy rebrand of DevOps or maybe something in between. So worth sticking around. Just out of curiosity from the folks here, how many, with a show of hands, have platform engineering in their organization? Or think that they have platform engineering? And I don't care if it's called platform engineering or shared services or other names. Okay, leave your hands up. How many of you work with an organization of more than 100 people? Okay, how many of you more than 200? 400? 1,000? Okay, 2,000? 5,000? Okay, remember that. That will be very, very relevant for us. So let's start talking about platform engineering, but first let me introduce myself. My name is Dotan Horowitz. Actually, some people told me that according to my surname, Horowitz, I have origins here, so I guess at some point I have affiliation with Czech Bohemian origins. I work as the principal developer advocate at a company called Logs.io. Logs.io provides a cloud-native observability platform called Open360 that's based on popular open source tools, some of which you already heard about today on the lectures, like Prometheus, OpenSearch, OpenTelemetry, and others, and provides them as a managed service built for scale. I'm also a CNCF ambassador. CNCF is the Cloud Native Computing Foundation. We're all here at the KCD, so I assume everyone knows CNCF. So if you have any questions about the CNCF, about the Cloud Native ecosystem, feel free to grab me after the talk. Happy to talk about Logs.io or CNCF or observability or many others. I also have a podcast called Open Observability Talks that discusses open source, DevOps, observability, platform engineering, SRE, and the likes. So if you like podcasts, it's in English. Check it out on your favorite podcast app. And not many know, but I'm also a platformer, as you can see here from the tweet here, from the picture. So this is why I'm here to talk to you about platform engineering. And you can find me everywhere at Horowitz, Twitter, Mastodon, LinkedIn, Medium, whatnot. So if you have any questions and you're shy to ask here, feel free to follow up on me also there. And with that, let's talk about, before platform engineering, let's talk about DevOps, and mainly about what are the challenges of DevOps that we come to solve with platforms, and especially DevOps at scale. So as your organization grows, and you have multiple product teams and multiple product lines and multiple business units and line of business and so on, then you start seeing the following symptoms that you can see here. The first thing is the toil. You start realizing that different teams, different product teams, solve the same problem again and again, each one for their own teams, in silo. Not knowing, mostly in many cases, not knowing even that other teams solve the problem, or even if they do know, the other team solved it so tightly coupled with their own product that it's too much of a hassle to take it from them, and they rather just start from scratch. So that's one problem. The other problem is the cognitive load, okay? We all know shift left. Apologies for those who attended the panel that I participated earlier today, because I talked a bit about shift left there, so I'm repeating. But essentially, the shift left that gave more responsibility, more ownership, more independence to the engineers also came with a lot of baggage. And the baggage is the skill set. Suddenly, the product engineer is expected to know about Kubernetes, about Docker, about Terraform, about Jenkins, about a gazillion other things that are more infrastructure related. And that's a lot of cognitive load. And it's also a defocus, because that product engineer needs to ultimately develop the product, the core business logic of that application. So all of that is pretty much a defocus for that engineer. And the last problem is the fragmentation and inconsistency, okay? There are multiple ways within the organization for creating applications. There's no right or recommended way of doing things. Developers can get confused having multiple ways of doing things and finding the right way of doing things. And also very hard to enforce conventions, security, and compliance, because each team reinvents it and does it locally. And this is exactly the background for introducing platforms and platform engineering. Don't reinvent when you can reuse and adapt. That's the premise that led to platform engineering. And remember that. Don't reinvent when you can reuse and adapt. So now that we understand the premise, the grounds on which platform engineering grew, let's look at what platform engineering is. So, and this is my definition. I looked at actually in the canonical definition. I found lots of them, and none of them I liked. So I'd rather just bring my definition and, most importantly, break it down to the very important elements that I think you should take out of the definition. So the platform engineering is a DevOps approach in which organizations develop a shared platform to improve the developer experience and the developer productivity across the organization by providing self-service capabilities with automated infrastructure operations. Now, I want again to highlight the main things to take out of it. First of all, it's a DevOps approach. It's not a whole different beast. It's not something else. It's a DevOps approach. And I'll touch upon the relationship with DevOps in the coming slides. And the purpose is to, first and foremost, to improve the developer experience and developer productivity. How do we do that? With a self-service set of capabilities provided across the organization as shared services. Okay? Now, definitions are nice, but I'd like to just go over an example to make it very concrete and simple. And I chose the example that I heard actually from the director of platform. I think they called it Cloud Platform at Citrix, very large organization. He gave me that example as part of an episode I had on my podcast, Open Observability Talks. So you have the QR code here at the bottom if you want to listen to an exquisite episode about platform engineering. But the example is very much representative of the dynamic. So they identified that different teams invested significant effort in certificate rotation. Again and again and again, different teams doing the same thing. So then they went, and very importantly, they didn't go about implementing. They first went to the teams, quantified the benefit by understanding how much they invested, in their case, 300 story points, for implementing their in-house solution, their in-team localized solution. And then they estimated that integrating a platform engineering centralized shared service would be 50 story points. Okay? Now, that's one team. The value is clear. Once they got the buy-in, they went ahead and implemented and provided the self-service certificate rotation as a shared service across all the teams. Okay? So that's, in a nutshell, platform engineering and also the dynamics and the flow that you should be taking. Now, we talked about DevOps and platform engineering, and as you've seen from my definition, platform engineering is not a whole new beast. It's actually a DevOps approach. Okay? So what is the relation between DevOps and platform engineering? I get that asked many times, so I put a couple of slides to explain that part. So we all know DevOps, and DevOps uses tools to streamline deployment, management, and monitoring using automation and visualization, right? Platform engineering takes these tools, best practices, and processes and productizes them as reusable services and tools for use across the organization, across the different use cases, across the different product teams. Okay? And remember that word, it productizes them. That's the operative word here. Another way that I like explaining that is looking at the DevOps maturity model. So the standard model goes from initial to managed, defined, measured, and optimized. And when you're in the managed and defined, the earlier stages, you'll see that typically each team creates its own DevOps practices to fit the needs. Usually the deliverables at this point would be blueprints such as Terraform templates, Terraform modules, Docker images, configurations, and so on. And then engineers clone that and add their configuration and use that. But as they clone it, they actually detach from the origin and they lose the connection, okay? And obviously, this is siloed. So actually, there was a very good discussion this morning for those who attended Philip's lecture. I'm not sure if Philip is still here, but about package managers. I don't know who attended that session. That session actually was also echoed some of that pain because he talked about, for example, about Kustomize. Kustomize with a K. It's a project that used to be about package management and how it used to be popular at the beginning, and then it was pretty much neglected by most platforms today. And the reason, by most products, sorry, as package manager recommendation, because of the pain it took to utilize that and to adapt it when you talked about when you had multiple instances across the organization. So you need to clone the GitHub repo, make the configuration, and things like that. And we see similar pains also with Helm charts. I don't know how many of you need to manage multiple Helm charts, and it's becoming a pain as well that you need to do that. So this is the pain. He talked about it from the tooling side. I'm talking about from the processes side. It's becoming a pain when you have multiple of those. And also localized in individual teams. So remember that we're talking about localized within individual teams, so little correlation to other teams and other efforts across the organization. So this is in the earlier stages. Now, as your organization matures and scales, you move your DevOps maturity into the measured and optimized phases, then the organization starts collecting data and understanding the impact of the DevOps practices across the organization, actually measuring and quantifying it. And then this exposes these pockets of inefficiency where you pay the same toil again and again and again across different teams. And then in this case, the need for consolidation with a shared platform becomes very evident. This is the point where platform engineering becomes material to the organization. And this is, by the way, why I asked at the beginning of the lecture the question about what size of organization you're at from those who do have platform engineering, and you saw that it's the larger organizations that have this facilitation, okay? This instance of platform engineering. So I wanted to bring the use case of another large, high-scale organization like that with platform engineering, Spotify in this case. Actually, Spotify launched their own platform, do-it-yourself from the ground up, and actually later they released it, they open-sourced it and donated it to the CNCF under the name Backstage. A fascinating journey. I'll mention Backstage later if time permits. But they shared the numbers about their engineering organization internally, and they showed that their developers are 2.3 times more active in GitHub. They create 2 times code changes in 17% less cycle time. They deploy software 2 times, twice as often, and their software is deployed for 3 times as long, and 5% more likely to be at Spotify 1 year later. And yes, cognitive load also bears cost in terms of losing good engineers and the churn of engineers. So this is definitely something to think about. You have the QR code for another fascinating episode I had with the director of platform at Spotify. She relayed very nicely here about the story, so check it out there. But anyway, I want to talk about shared services. Okay, and shared services, I keep on saying shared services, but it rings a bell, right? Rings a bell from platform as a service, PaaS. I don't know how many of you remember this period where we divided all the migration to cloud and cloud IT into this very neatly set IaaS, PaaS, and SaaS, infrastructure as a service, platform as a service, software as a service. Who remembers that? Okay, we have a few that went through that era. So essentially, the problem back then was very simple. IaaS was okay, it was pretty stable then, especially with AWS. We had the compute instances, we had the networking, we had the storage. And then many tried starting businesses as SaaS model on top of cloud. And then they realized that the gap is very big. I need to create my, I don't know, e-commerce thing or online shop or whatnot. Doing that straight on top of the IaaS was very, very low level. And this was the ground for building the PaaS. Things such as Heroku, AWS Elastic Beanstalk, Google App Engine. And they brought a very elegant solution. You get very nice simplicity. I want one database, I want one caching solution, one this, one that. You plug it, you create the relation, the connection, and that's about it. Okay? But it didn't catch. How many use any of these PaaS services today? Anyone? Okay, we have 1, 2, okay, 2. So the most of us don't use that today. So it didn't work. And then the question is, okay, you bring platform engineering, all this buzz, is that ultimately PaaS all over again? And I've been through that PaaS era. I even worked at a startup called Cloudify that was squarely in this business. It was then sold to Dell EMC and all of that. So I lived that, and I'm here to tell you, no, it's not PaaS all over again. And I want to explain to you why PaaS, in my perspective, didn't work, so that you can see why platform engineering takes a different approach, or at least should take a different approach if you apply it correctly, and I'll tell you what correctly is. So PaaS had a few problems. One, it was too opinionated. As I said, you got one database, one thing, but it doesn't work that way these days. These days, you see the organizations have different runtimes, deployment methods, and so on. We need more flexibility than that. Secondly, there was vendor lock-in. Okay? If I wired all my infrastructure with Heroku, that was what I got. I got Heroku and I'm very much locked in. And a related problem is, what if I have already Terraform and I have Docker images and I have other assets? How do I reuse them or even migrate them? Okay? So these are the problems with PaaS. And what I'm here to tell you is that we don't need platform as a service. We need platform as a product. So how is that different? It different several material aspects. First, it's developed by in-house platform engineers sitting side by side along with your product engineers. So they can actually go there and understand the feedback and create short feedback loops to make sure that it's suited, okay? That was when I was a product manager in past life, that was my dream, to go to the users, get feedback, sit and see with them and see how they use it, get them to answer surveys and so on. It's very, very difficult, trust me, when you do that with external users. Now the users are part of your company. You can actually do that much, much easier and get their collaboration and feedback, and without any problem of exposing internal issues and so on. So that's on one side. Secondly, because it's our own platform engineering team, it's suited for our organizational conventions, tooling preferences, development and deployment styles, compliant constraints, and so on. And thirdly, and very importantly, it's also, or it should be, optional and composable. I also stressed it out for those who attended the panel discussion earlier today. I'll stress it again here. Optional and composable. So every team can take whatever suits it out of the pile. They don't need to buy into your entire suite, entire platform, all or nothing. They can choose, pick and choose what suits them, and from the inventory, from the catalog, whatever it is. Treating your platform as a product starts with treating your engineers as your users. And that's very, very important. So really, it calls for a product mindset, and I see a fellow here that knows the need for that. We chatted about it earlier, and I want to emphasize that. Maybe, again, because I come from product background, but let's be very clear. Everything that you do as a product manager for external products, you need to do here. First, user research. As I said, the fact that there are your engineers in the product team in the same organization does not mean that you know their pains. Go to them, sit with them, understand their requirements, understand their pains and needs, and define their requirements based on that. Secondly, be data-driven. Quantify the value, measure the success. And thirdly, balance simplicity with flexibility. We engineers are very problematic beasts. On the one hand, we like simplicity. Don't bother me with all the details and all the under the hood. Just give me something that works. On the other hand, we want all the flexibility. Hey, in Docker, I could do minus this, and I could do that. Are you abstracting this away from me? No way. So, as a product manager, you need to balance the split brain and strike the right level of abstraction. Now, in addition to the needs arising from the various individual product teams, you also need, as platform engineers, to also address cross-organizational requirements. So remember, when each team implemented its own stuff, it was very difficult to enforce security and compliance. Now that we have a central platform, it's become much easier. So this is an example of a very important value of platform engineering. So you can see here compliance with relevant regulations, standards across the organization, establish consistent conventions, standards, and style guides, and also cost efficiency. FinOps approach, consolidating vendors. Think about each team going to a different vendor. Less of a power that you have with that vendor, and less someone that can actually meddle with that. Whereas when you have a central platform team consolidating, you come with more volume, you can come with someone who can bargain better deals, reduce the costs, maybe even doing multi-tenancy, sharing resources between teams across the organization, and so on. FinOps-wise cost, something that is very important these days for many organizations. Also reducing overhead by instilling best practices and golden path solutions. So benefits and needs that platform engineering serves centrally beyond the individual product teams. Now I want to look at what the platform capabilities are, and I used the model that is taken from a white paper that came out from the app delivery TAG, a technical advisory group within the CNCF. A fascinating white paper. You have the QR code there. You can scan and check the full white paper. I wanted to highlight the model that they provide. So you can see, let's start bottom up. Obviously, at the bottom, you have the infrastructure, the cloud providers, and other platforms that you use. And then the platform capabilities surround a lot of a suite of capabilities, environment and resource capabilities, like runtime environment, Kubernetes, infrastructure, databases, caching, messaging queues, and so on. There's also, this is the production, there's also the release lifecycle elements like pipeline, build, CI/CD, think about your Jenkins, Argo, Flux, and so on, even chaos engineering in some advanced cases. Could even be the dev environment itself, like managing the repos and the registries. Think about your org Docker registry or a Git repo and so on, SBOM management, even dev environment as a service. I gave this example earlier on the panel. And security-related identity, RBAC, AAA, like authentication, authorization, access control, static code analysis, making sure that each team does static code analysis, artifact scanning, policy enforcement, all of that you can embed it as part of the shared services, secrets management, certificate management. That's on the security. On the observability, I come from the observability space, so that's what I do day in and day out. And all the suite of observability, which includes the code instrumentation, enrichment, local daemons, collectors, sampling, aggregations, roll-upping, indexing, storage, visualization, alert management, all of that, someone needs to take care of, okay? So again, as a shared service, for example, with my company, this could be an element with Logs.io that you provide, and then you get the end-to-end solution on the observability piece, okay? In some places, they go into even higher level, like business-related reusable services like billing, metering, cloud account management, and so on. So it's really up to your organization where the line draws. And what it provides above, you see the platform interfaces across UI, API, and CLI. Including web portals. Many talk about internal developer portals, self-service APIs and CLI tools for automatically provision, and golden path templates and docs. So check out the white paper from the Tag App Delivery. And there's another one, white paper about the platform maturity model, fascinating work by the CNCF. Now, I mentioned Backstage, so just briefly, Backstage, that project that started as an internal developer platform at Spotify, and then they open sourced it and donated to the CNCF back in 2020 to the sandbox and moved to incubation in 2022. And by now, you can see very impressive numbers, 150 plus plugins, 3,000 plus companies adopting it, 25K plus stars on GitHub, and thousands of forks and more. So really impressive. As I mentioned, there's a very nice episode with the director of engineering there that talks about both the internal development and then the open sourcing of that project and donating into the CNCF, and what that made and how that boosted the project. Fascinating journey. So we're about to run out of time, so I want to summarize what we've seen. Several important things. First, remember that. Don't reinvent when you can reuse and adapt. And the reuse and adapt, that's exactly the piece that platform engineering should provide. So platforms improve the developer experience and the developer productivity by removing toil and cognitive load. Platforms promote cross-organizational consistency, security, and cost efficiency beyond the individual developer experience and productivity. And as your organization matures and scales, then you'll see the need. So if you say, I don't see these pains, maybe your organization is not yet there. Don't enforce platform engineering when it's not really needed, when you don't see. It will come naturally as your organization grows and scales out. And lastly, but definitely not least, treat your platform as a product. So again, if you want further reading about this, I have an article I wrote already, I think, 2 years ago about platform engineering. You're welcome to check it out. Provides much more in-depth about the points I touched upon here. And with that, I'd like to thank you very much. I'm Dotan Horvitz, and thank you very much for listening.
Thank you, Dotan. So we have at least one question. I'm going to read it. So in the last years, following the DevOps hype, we saw appearing dozens of XOps, such as FinOps, ToolOps, DataOps, GitOps, MLOps. So what's your view on this?
Okay, that's a bit off topic for platform engineering, but in a way it's related because platform engineering does serve some of these. So I think at least on the ones that you mentioned, I don't know all the X's, probably I'll find some new, but I definitely see that FinOps is real. I see that actually very much increasing in the last couple of years, that it's becoming a concern. And actually I see many organizations realize that once they get a proposed the maturity model into the measured and optimized phase, they realize the pockets of inefficiency also on the FinOps side, like instances that run idle for a lot of time and not shut down, like underutilized and so on. So I think FinOps is very real, and projects to optimize, to reduce internal cost have been proving like tens of % of improvement in the cost. So that's definitely real. Security, we don't need to talk about it. Whether DevSecOps is something different, a different beast than the traditional security is a whole different lecture, but definitely it's a topic. So I think they're material, and I think it's important to also understand it's not a role. That's something that people tend to get confused. So do I hire now a DevOps guy? Do I hire a FinOps guy? Or is that a discipline that we need to instill within the organization? And this is something that I see oftentimes, that they see, okay, I tick the box because I have a DevOps guy, so I have DevOps. No, you don't have DevOps, and it's same for FinOps and for DevSecOps and so on. You need to, like in platform engineering, you need to instill a culture where you have this in place, each one with its own respective thing. So I see that also shifting left more to developers, or developers take more ownership in the security, DevOps, and so on. That's my take in a nutshell.
Thank you. One more. What do you think are the important first steps building a platform in an organization following the Go decision?
So I think it's very important. If you got the go decision, the green light from the leadership, it's important to understand what was the thing that ticked the box. Like, what was the OKR, the objective key result of the organization that you got them bought into that. If it's, for example, preserving engineers, reducing the churn in engineers, whether that's increasing the dev velocity, because that will be also your top OKR for your project. So that's one, to know what you're trying to show afterwards to leadership, that the project success achieved its goals. Then you need to find the sweet spot to start. Sweet spot is like, we talked about the pockets of inefficiency. Find the most obvious and painful pocket of inefficiency. Recurring in many teams, touches a very sensitive point to the organization, something like that. Use that as your beta, your pilot, your proof of concept for that. And then find your champions. You don't need to tackle it across the organization. Find one team that is more early adopter, that is more bought into the idea. Do the pilot with this team, then find the success, show it to the other teams within the same shared service to get this shared service propagating across different teams of organization. Then you have one shared service as a success across the organization. Then you show that. Then you find the next one. This is how I would do it in the first phases.
Thank you. Do we have any other questions? Maybe one more, last question of the day.
Come on, I couldn't have been that clear. Okay, so feel free to reach out to me also in private if you're too shy, or reach out at Horowitz in whichever medium you like. And thank you very much for listening.
Thank you.